Welcome to part 2 of our webinar for creating your own module for the modular application creator. In the last lesson, we were creating the data model and the view model. You can see it here in my tree. This should be what you have already achieved in your own module. And this is where we keep going. In the second part, we will focus on the generation of actual TiaPortal elements. These TiaPortal elements, there are quite a variety of elements we would like to create. Here I'm going to show you one project that has already been created with the Getting Started module. And this is quite what we would like to achieve with our generation of today's lesson. Just to get a bit of an overview, we would like to, first of all, have the libraries included. I will show you what libraries we're talking about later. It's basically a TiaPortal library that we prepared. So we would like to have the elements from this library. It's called FlyingSaw Basics. And we would like to have these elements. In this case, it's like some blocks, some function blocks that we will use for the program later. There will be PLC tags for this library, and there will also be PLC data types, as you can see here. So we would like a program that generates all these into our existing TiaPortal project. So the PLC data types, which come from a library, same with the program blocks that come from a library. Additionally to this, we would also like to create some function blocks and data blocks of our own, because we would obviously need them for basically controlling our module. So we cannot rely on libraries alone. Obviously, we need to adjust those functions to our use case. And the basic software part for this we can find in this FC with calls for OB1. I think it's obvious what this is supposed to do. This is a FC that is called in the main OB1. I will show this in a second. We basically just do this to have a bit of a encapsulation. So we could also write this directly in the OB1. That would not be a problem at all. But in our case, we prefer this solution because therefore we have it more on a, like, let's say, all in one place. And the user could add additional elements to his OB1 that are not related to our module. And everything would still be nice and clean from the code base, and we can have a good overview and not getting too, too much of a spaghetti code there. So the FC with the calls for OB1 is going to look like this. Here I just wanted to give you a short overview of how this is going to look, so you know what we're talking about. We're going to create a global DB, which I also show you very quickly with a data structure that you can see here. Don't worry, we will go into details soon, just so you get an impression. There is going to be an instance DB, which is being automatically generated. We will make use of the functions from this library, as I said. And the last two parts is the technological objects. We would like a technological object for each our cutting axis and our infeed axis. And we would also like to create a TagTable for our case with this. It's called these demo case IOs. Here you can see some functions, some tags that we will create here. And this is our aim for today, to create all those elements. And of course, we will fill the data with data from our objects that we will create, like our infeed axis and our cutting axis. They have special properties. One day it will be possible to set those in the UI. And of course, you would like to have them in a generated program, and so they have to be accounted for in the generation. So yeah, as I said, just a short summation. We want to create libraries for the PLC data types. We want to create a library for the PLC program blocks, all within our TiaPortal. And we want to create a FC and call this FC also in our OB1 main block, as you can see in a second. Here you can see this block is being called. All of it is generated automatically by the modular application creator with the help of your module. So this is the task for today. And the first step usually in such a module is to select your library that you will use for underlying functions. Here in my case, I've prepared the library already, and I will show you quickly this library. So here I've already opened it. It's called lib FlyingSaw basic, but for the name you can choose whatever suits you. And as you can see here, we basically only have master copies. There's also one type, but this is not going to be used. We have these master copies, which we rely on. Just for information, the modular application creator is able to also work with types. You could also create types like PLC types for this blocks, or also for these PLC data types. That's all possible, but we would like to focus on the master copies for now. But the handling would be totally the same with the types too, so do not be afraid to use that. Here you can see the FlyingSaw basic blocks, as it's called, the folder. This contains all the FBs, and if you remember, you will always also find them here. You can see these are already included in this project. As I said, this project was generated with a finished getting started module, so yeah, we would expect them here. Same goes for the data types. We will find them here in this folder. This is a bit more files. I will not go through all of them, but you can see here the structure is the same. The blocks are all there. And same goes for the types. We only have one for the tags. We have one tag table, which you can see here. And the tag table that we can find in this library is not quite the same than the one generated. I will show that quickly by adding it here. Hang on. I'll show you first how it is after the generation. After generation, you can see here we have all these tags. And the point is why I said it's not the same in the library. In the library, the tags that exist are only these eStop and H0 to H15. Oh no, sorry, just H0 to H15. These are already tags that are already there in the library. And what we are going to do is we are adding some tags like this eStop, this general power, HomeSaw, move in feed access tags that can be used later for controlling your program. So as I said here, the H0 to H15 tags will be there, and I will just show you this quickly by actually adding this tag table into the TiaPortal project by hand. I will here say, no, don't replace the existing one, so you have the existing one. So for showing you the difference, I think this is the easiest way. So now it has added those. And I'm just opening this table very quickly. So here you can see, of course, the tags are already there. H0 till H15. Oh, actually, eStop is also there. So it was wrong with this. Doesn't matter. But you can clearly see that the other tags that you have seen in the previous one, here you can see it again. General power to enable auto mode cutting. They are all not yet existing, and we will try to add them on our own during the generation to show you guys how to create these tags by yourself. So, as I said, first thing is to start with an existing TiaPortal library. This is usually the base for each equipment module. Of course, you could also go without it, but from experience, most of the complex applications that need to be generated with a module for the modular application creator, they're usually rather complex and therefore rely on these libraries to provide them with some of the advanced functions. But as I said, you can also go without. But here, as we said, I show you how it's done with those libraries. So step one is we go back into our Visual Studio project and we're opening this .tiares file in our project solution. And if you press this, you will see that some kind of window is opening. So I'm just expanding this window to maximum size. And here you can see on the right side these 4 folders: technology, objects, program blocks, PLC tags, PLC data types. These are all the folders that can be created in your TiaPortal project automatically. Basically, same as I just shown you. So you will get such a libraries folder with the subfolders depending on the structure of your library. They will all be automatically created if they have some content. So in my case right now, I have not added any library. So you can see there is no content. You only have this module instance folder. This is something you cannot delete. It will always be there in this view. If there's nothing in this module instance, then the whole part will not be generated. You will not have an empty folder in your TiaPortal project. Only if you add content into it, then it will be created. So these module instance folders are always there, and this is like kind of the pre-configuration. And as I said, they will only be there if you generate something actually. And these module instance is a bit different to the libraries folder. So you have like the program blocks, technology objects, PLC tags, data types. I think it's clear. That's, as I said, are like these categories that TiaPortal has. But then in the Mac, you have let's say two different subgroups in each. You will see it very soon once I added the library. So in order to add an actual library, I will press the button in the top left corner. Can be a bit difficult to find. It's not that obvious in the beginning. But then I go to my folder where I have my TiaPortal library. Here I've put one on my desktop. So to find it easily, I select the TiaPortal library file. So just like you would do in a normal TiaPortal project, you press open. So my import was successful, as you can see. On the left side, you can see some folders. These are the folders from my library. So this is actually the content of my library. And on the right side, you can see the folder structure that is going to be created by the module when you generate with the Modular application creator. So right now you can see that on the left side, I've got a folder master copies and types. So this shows me all my content that I would like to, or that I could use from my library. And here now I could basically select what parts of my library am I going to use in my project. So typically most people would say, yeah, just use all, just give me all of the content. And oftentimes I find it quite viable to do. But of course you could also select only some parts of it. I want to show this, for example, with the PLC types. So for example, we have this measuring input subfolder in our library, and we just want to have this PLC type for whatever reason. So I could say, okay, just add this specific part. And here you can see that now you got a kind of a little symbol that shows you that this current element is already included in the library. Like now it was included. And if I look in my folder structure in my library, I will be able to find it. So here I go down and see, yeah, it's there, it will be generated. And you can see the folder structure is the same that we can find in the library. So here it will mirror the folder structure in the library. And this folder structure that you can see here on the right is also the folder structure that you will be able to see in your resulting generated project. So for this type, for example, FSMI status, we would be able to find it in our TiaPortal project. So we have this generated TiaPortal project that I was showing, and here I can directly go down, scroll down in the hierarchy and find my FSMI status. And if you look at the folders, you can see the folder structure is the same. Maybe the only difference is here that this subfolder is called lib FlyingSaw basic _ types. And if you look back, we can see here it's only basic without the underscore types. This is because there's like, let's say, the convention that the module will create, first of all, the libraries folder. You have probably seen that. The next one would be named after the library, but it would make the distinction that here, since we are in the PLC data types section, it would add the types. In the same way, if you look at the libraries for the blocks, it would add these underscore blocks. Other than that, it's all the same. It's all the same structure. And here, as you can see with the blocks also, we have the same structure. And what you could do is to change the structure. You could, for example, say, oh, this FSMI status type, I don't want it to have it like in this subfolder. I want it, let's say, one hierarchy above. And then we have it here in this FlyingSaw basic types, where I can also put it some other place. Just with drag and drop, you can put it into any folder that you wish. Or you could also create new folders by right-click and say add new group. Then you can just name it to whatever you want. My own group for types. And then add it to this folder, for example. And then if you generate this project, then you would find this type FSMI in a folder that is called my own group for types, which is in a folder FlyingSaw basic measuring input and so on. I think the concept is clear at this point. So here, this way you can change the location of the types, and you can actually select which types and also which other elements to generate. As I said, the most basic use case is to just generate everything. And this is what we're going to do here. So I'm going to remove this group. I'm putting it back in this original hierarchy. And in order to add all of those master copies, I just press right click on the master copy folder from my library and it just press add. So now it's loading a moment and now we have it. So you can see here my subfolder FlyingSaw basic measuring input. It has got some more content, like basically all that was here before, and also every other element which is in the master copy folder is here. Same goes for the program blocks and same goes for the PLC tags. So this is already quite good. At this point, if we do the generation, all these elements would be generated. That means we would have an existing library generated into our TiaPortal project without having to do anything else at this point. So here we already achieved quite a bit. And if you look in the resulting TiaPortal project, of course, you can see here the libraries folder, everything is as expected. We have all the function blocks that you can find in the library. Here we have all the types, and you can always see this libraries folder, then the folder with the name of the library. Same goes here. Maybe you're wondering why is it not happening for the PLC tags? So why is there no libraries folder here, despite we obviously added PLC tag table. Here you can see it. We have the name libraries and the subfolders, but in the resulting TiaPortal project, this doesn't exist. It's not no subfolders, no library folder. And the answer is simple. We have this module instance folder. I was mentioning it before. I said it's always there, but it's only generated if it actually has content. And now you might wonder, what does it have to do? Because here you do not find a folder that is called module instance. And also here, the basic idea of this is that this module instance name, this name module instance, it's just a placeholder. So each module that you're adding to an existing project and the modular application creator gets a unique instance name. So if you're adding a module to the modular application creator, like in the UI, you will be asked what is the name of your module. Like this is the first question when adding it, and you can just give it any name that you want. You can name it whatever you want. This has nothing to do with functionality. It's just the name of the instance. And this name of the instance, that's going to be parsed into this placeholder. So in my case, the instance name of the module that I generated was getting started. Of course, the module, the general name of the module is also getting started. So do not confuse that. There's a difference between instance name and the general, I don't know, let's call it class name. So class and instance name don't have to be the same. In my case, it was the same. So that's why we have this getting started folder. This is basically the instance, module instance folder. And every time you see this getting started folder, this is the module instance folder from the tiares file that I just showed in Visual Studio. And here in our project, you can see we have this getting started, this instance folder here at the program blocks. And we also have it here in the PLC tags. And this is where our tag table is that we want to generate. So in order to get this tag table into our module instance folder, what we do is we go back to our tiares file to set up our library and folder management. And here you can see, if you go to the PLC tags, you see this demo case IOs is currently in this library folder. So if you generate now, it will be in the libraries folder. But as I just said, we want it in the module instance folder. So we drag and drop it down to the module instance folder. And now it's there. Very easy. So we remove this group. Normally it should not be generated if nothing's inside of the group. But yeah, just want to be sure. I don't want to have some empty folders lying around. So this is it. And this is all we have to do in the PLC tags. So only changing this tag table into the module instance folder. That's it. No more changes. The PLC data types, I'm happy with that. There's nothing to be done. Also, we do not use the module instance here because we do not want to create our own data types. So this is also done. Can be closed. Technological objects also is being handled in a different way. We do not use any technological objects from the library. And also here we could generate technological objects into the module instance folder. But in our case, we just generate them directly into the technological objects in the general technological objects folder. This is because the basic functionalities that we get from the modular application creator, they're easier to do this way. We could also put it in a subfolder, but that's not what we're going to do here because we don't have the functionalities for this library handling and for technological objects are, how you say, a bit separated. So it would be a bit of a, let's say, hassle to actually get that done. So we go the easy way and just generate them in the general technological objects folder. So here's also, don't have to do anything. Only thing we have to do is to create some module instance folder for the program blocks. You probably have noticed that in our function block structure, we have this getting started folder, but then we have some subfolders. And as I said, they are here for just basically taking care that we have a nice divided areas for each of the types. Like for our data blocks, we have an own folder. For FCs, we have an own folder. Could make one for the FBs. And in order to achieve that, we can also create some folders in this tiares that we later use during the generation. So therefore, we use this module instance and create a new group. And the first group I will just call FCs. Second group will be called DBs. And if we look in our resulting project, what we also would like to have is a distinction between global DBs and instance DBs. Because normally the global DB can be used for basic configuration, maybe even the control of the project on runtime. And so you want to find it easy and nice. And the instance DBs, normally you don't need to look at them much. They have to be somewhere, but then most of the time they're not being used much. So you want to put them in our own folder that we can just close and forget about. and therefore we create like its own global folder and an instance folder for the DBs. Same way as we have done before. On the DBs. Creating already a second one, and then it just rename them. So now you can see that this structure with FCs, DBs, global and instance is very much like the structure that we can see in our resulting project. So, and this is basically all we have to do in this tiares file. So here, if we would generate now, you would also get these folders and the libraries, but of course, no more content. So just to summarize what we have done, we added this library, we added all the master copies from the library. Here, just to mention, we did not use these types because we do not use them. We just want to use the master copies. We added them to our library. Basically, the only step you have to do is press the add button. I already did that, so this is gray now. But then the library is being already created here in its original structure. Then we changed the TagTable from the library folder to the module instance folder. And last, we created a folder structure for our module instance program blocks. So yeah, at this point, we are done with this tiares and we can close it. We are now back in our, let's say, in our normal view of the Visual Studio project. After leaving the .tiares, which, let's say, it seems a little bit like its own program, but yeah, it's also part of the Visual Studio project, obviously. And you might notice now that there are some changes to our project. You can see on the left side that suddenly we have this folder generated classes, and there are a lot of classes in there. And if you look at the names, you might notice that they are exactly the names of the data types, of the blocks, or of the tag tables that we included. And this is, of course, not an accident. And as you can see here, if you look into these classes, you can see, first of all, and you should really take it serious, they are auto-generated. And here, it's important, changes to this file may cause incorrect behavior, and most of all, will be lost if the code is regenerated. This means basically, if you open this tiares again and close it, these files will be recreated. If you want to make changes to these, basically don't. There are exceptions, there are situations where it might make sense, but these are very, very small use cases for that. In general, and for a starter, I'd say do not do anything here. Follow the advice that is given here and just leave it as it is. Here, maybe for information, what is written here is basically a lot of, let's say, meta information of defining the classes which are being used internally in the modular application creator. That should not interest you. Maybe the only interesting thing could be this part, because this is basically the path to this file within the TiaPortal library. So what the module does is it actually stores the library that you added. And you can also see that here in the project structure that you have this zip file, lib FlyingSaw basic.zip. So the module creates a zip file where, like, if you open the zip file, there's like just a TiaPortal library as is. You can open it, you could do anything. It's not, how do you say, it's not in a different format or anything. It's just plain TiaPortal library. And here in this class, you find the path to these elements. So this class that I currently opened is the demo case IOs. This is the tag table that we were moving. And this tag table, yeah, goes into the FlyingSaw basic tag, or is found in the FlyingSaw basic tags folders. Yeah, and then name as 210 demo case AOs. So this way, the generation logic would know where to find it once it starts generating the library files. But also, as I said, you do not need to change anything. If you want to make changes, for example, if you want to say, okay, I don't want to have this tag table in my module instance folder anymore, I want to have it back in the libraries folder, always do this in the tiares file. Tiares file, as I said, is the file here that you find. Every project has one, and you just double click on it and it opens the editor that we've seen. Always use this way. It's really strongly recommended. So here, all these classes, they're basically very similar. They all look similar, giving you this basically this path. And yeah, at this point, there's not much more to it. Another point that is also automatically generated after using the tiares file is this ResourceManagement class. The same goes here. This code was generated automatic. It will be lost if it's regenerated, or its changes to it will be lost if it's regenerated. So also do not make changes here. This is just for information purposes. Here you can find basically the logic that is being used to generate this TiaPortal library into your TiaPortal project. So here you find some functions, create instance DB, create instance DB with standardized name, like functions that we will use later, some of them. Many of the functions are being used automatically within the generation routine, like for example, delete existing instance groups. So everything that has been generated before by this module will be deleted. Like if you do a second generation, then everything that you created in the first generation will be deleted, and therefore this function is being used. And if you use the reference to see where it's being called, you can see that here you have this generate functions where basically all the logic happens during a generation. It's really not important for you to understand what's happening here. It's a bit complicated. There are probably some use cases where it makes sense to also make changes to this file. But here we will not look at that because that would go a bit too deep, and for absolutely most of the cases, it's not necessary. It's just important to know this file exists, and maybe it's important to remember, do not change anything here. Do not play around with it. You might also be able to make changes so the generation doesn't work anymore. So yeah, have a look if you're interested in it, but yeah, please don't change anything there. And if you do change anything there and you're like, oh, I changed something, it's not working anymore, then you can just open and close the tiares file again and it will be regenerated and you get like a shiny new resource management file for your library. So one possibility that you have with this resource management to make a good use of it is that you can, even on runtime of the program, decide which parts of the library to generate or not. So there could be situations where you basically include all of the library into your project because you might need all of the functions that the library provides, but maybe after setting up your module configuration, it gets clear that some parts of the library are not needed, and you might not want to generate those. Maybe you have to save some space on the PLC, or maybe you have some, let's say, safety functions, and the user does not use a safety PLC. So for these cases, you can define in the generation method of the module which parts would you like to include and which you might not want. So the possibility here is to, or the best way to do it is to use this GenerateTiaPortal function. This GenerateTiaPortal function, I would like to introduce you to it in the next few minutes. This is always is created automatically when you create a new module. So the steps that we showed in the first part, when you use the module builder to create a new module, you will always get such a function. And do not be intrigued to think that this is useless just because it says here it has 0 references. It is being used, and this is the basic point where you can add your code for the generation. And it's the only place where you can. It's being called by the frame application, by the modular application creator core application, which is not, I would say, it's not possible to see it here. You have referenced it in this equipment module Visual Studio project. That's why it shows these zero references. But this will be called, I can promise you. So in order to make changes to it, you need a bit of understanding of what's happening and when. I think the first part that's important is to understand there's a concept of generation phases. Here you can see there's a generation phase name. So this function is being called with a generation phase name. And you can see here's already a case, tia generation phases dot init. And if you press F12 on this enum, then you will be able to see what possibilities are there. So here you can see, okay, there's like a lot of phases: cleanup, init, post init, build, post build, refine, finish, complete, you name it. So these are all the phases where, let's say, things are being done. Not all of them are important. Usually, very few of them are important. Just as a rule of thumb, the init phase can be important, and the build phase is very important. All the others can be used, are not necessarily being used, at least not from the module itself. In most of the cases, it's more than enough to just focus on those two parts. And basically the concept is in the build phase, that's obviously when things are being built. So this is when the actual generation happens. And in the init phase, you do some, let's say, work that is required to set up certain parameters before the actual generation. So you might have some parameters that are not clear during runtime of the module, but as soon as the user presses the generate button, then actually they are clear, or you know what to use for, and then you can use this init function to make some last adjustments before the real generation starts. And in the build phase, that's, as I said, that's where the real generation actually happens. So going back to where we came from is the basic module. So you can see I'm in my getting started EM. So this is, as I said, the general module file that you have. And this GenerateTiaPortal function is always called. Here you have already, as I said, the switch case structure, which in this case only calls the init, but you can always add to it. You can here, for example, say, okay, case tia generation phases dot build, then do something, and don't forget the break. So this way you can add all of whatever you want to add. You might have noticed that we have two of these switch case constructs. So you can see here there's one switch case, and then, and this is an important part, we have this ResourceManagement.generate, which happens afterwards, also gets the generation phase name. So this also reacts to the different generation phases. Then we have here this for each that calls some control modules. This is basically used to also call this generation phase for all these control modules. I think this is quite obvious. What you might be wondering is, what is a control module? And I will just go very briefly into this topic because it's could be a complex topic, but we will not use it here, so that's why I don't want to spend too much time on it. But in general, it's possible for each equipment module, for the modular application creator, to use a variety of control modules. And these control modules are very similar to an equipment module, except they do not have an UI. So they can also not be added alone to a project in the modular application creator. What they do basically is they provide additional functions. So a use case for this could be that you have a control module which has a lot of very advanced functions to I don't know, let's say define drive parameters and drives. Or it has a lot of cool functions that help you in setting up technological objects or whatever your use case requires. If you have, let's say, functions that you use often in your modules, you might want to create a control modules which provides all those functions. And you can then just add this control module to your equipment module. And then you can always use these functions in your equipment module, and you do not have to create these functions in each module and maintain it in each module. So you could think of it a little bit like a library. I would say it functions very similar to a library with some advanced functions, with some special parts that are very special to the modular application creator. But the idea is very similar. So if you have any control modules selected, which we do not have in our case, then they would be called here. So since we're not using any control modules, this part is totally not interesting for us. So you can as well just ignore it. We could even comment it out at this point. I would recommend not to do it, because if you ever add a control module and if you forget to take away these comments, then yeah, that could be bad. So that's why we leave it in. But just remember, it's not required for our case because we do not have any. So for us, at this point, it's important to understand we have the resource management, which does its own generation. We have the first switch control for our module, and then we have a second switch control. And the reason why we have this is that this resource management part, this can be very crucial. It might do a lot of things in between, where we might be in a situation where we say, okay, I want to do something in my init phase, or I want to do something in my build phase, but I can only do it after the resource management has done its part. For example, if I wanted to do something to my TagTable, I said that this TagTable that you can see here in the TiaPortal project, we want to make adjustments to it. So we want to use the base table that we get from our library, but we want to make adjustments to it. And in order to make these adjustments, we have to make sure that this table actually has been created in our TiaPortal project, which normally happens in the build phase. But if my build phase of my module happens before the build phase of my resource management, then the TagTable would not be there in my build phase. So this would be the case here. If I go into this build phase here, this build phase is obviously happening before the build phase of the resource management. And the resource management, as I've mentioned, is going to create all these library files into my TiaPortal project. So this TagTable that we want to change is being created here in this resource management. And if I'm going to say, okay, here in this build phase, this first build phase of my module, if I'm saying here, I do something to this TagTable, then the program will say, look, I do not know which TagTable you mean. There is no TagTable with that name, or I cannot find any TagTable at all. So that's why you have the second build phase, which then happens here in this part after the resource management is done. And if you go here in this build phase, then your TagTable would exist. And the program would say, yeah, I know this TagTable. I will do the changes, whatever you require. So therefore, that's the reason why we have these two times these switch case instructions that basically seem very similar, but can have a big impact depending on which one you want to use. I show you one of the use cases right now that we have in connection with the resource management. I told you that the resource management has a couple of functions, and that also these classes that we have for our types, for example, for our blocks, for our elements from the library, that they do not have much functions. And this is basically true, but there are a few functions that I would like to show you, or at least one that can be quite important. And this function would be to basically say if you want or want not to have certain elements from the library included. So as I said, maybe you have a case where you say, okay, some of library is not required, for example, because it's let's say it's safety blocks and I do not have a safety PLC or for whatever other reason. To achieve this, I will add some nice code in here. I will add it to the init phase, and this code is determining if we are working with an FCPU, and then it says that only if we work with this FCPU, this type will be included in the TIA project. So what I use for this is this parent device property. It's already in your module when you create a new equipment module. And here you find information about the current selected PLC device. So here I can ask, is it an FCPU? Is it a FT CPU? And if it's any of this, then I can say, yeah, it's an FCPU, so it has safety functions. And in this case, I can say here in my resource management that it can be included. Or if this is FCPU property is false, then this type would not be included. Here, make sure to not forget the typecast. Otherwise, you will not get to that specific type, which is specific property that you need to change. So typecast is required. And why did I add it to the init phase? Well, I told you before that this resource management is also being called during the generation. In the init phase, it will initialize all the classes, or from the class it will initialize, let's say, a list of elements that it will create into the TiaPortal project. And creating those elements will happen in the build phase. So after the init phase, I would have access to, let's say, this list or these elements that are going to be created. And then I can give them or change these properties. So here, that's what I'm doing. I'm saying here, resource management, give me from this library this type. I do a typecast, and then I set the is included in Tia project property. If I would do it in the init phase before, like if I would add it actually in that first init phase, I would get an error during the generation because it would tell me that nothing has been initialized. It would not know where to look for this resource. So the resource management would not have, or like these properties, they would be empty or would be null. And you would probably get an iReference exception or something alike. So that's why you have to wait for the second time that this init phase is called in this block. So, I mean, the init phase is like happening once, and then it's going through this switch case instruction. It's starting the code from the first init phase, and then it does all this stuff in between. And then we go in another switch case instruction where we can, again, in the init phase, do some more code. But this time after resource management has done its own initializing. So here we can do it, and this way we would exclude this block for FCPUs. So this is a hypothetical scenario. As I said, we just imagine that this is the case, but in reality we need this block for our generation. We do not care about an FCPU. In this case, we keep everything plain and simple. So just as an example, I showed you this instruction, and I will also comment it out to not corrupt my generation. Write a comment to it so nobody gets confused. So, and this is how you can use this resource management to make actual changes to the library that's going to be generated. Now we are done with creating or with adding our library, and we are able to make some changes to it if we would need to. And now, if you generate your module, your library would already be created, but other than this, nothing else would be in there. So in the next steps, we would like to create some technological objects for our FlyingSaw and its objects that are part of this FlyingSaw. And in order to actually do this, we first of all need to create a FlyingSaw, because now our module is still a bit empty. We, of course, have created this data model and view model classes, but so far we are not using them. So far they have not been used at any place yet. So we need to create them and store them, of course. So the first thing we do is to find a place to store them. And typically we would like to be able to store them for later use and also for saving it. If you close the modular application creator and open it again, and you open this project, then you still want to have the same settings that you had when you left. So you need to store it somewhere. And that's what we do here with this part that I'm adding now. We create two observable, it's one observable collection and one, let's say a field that accesses it. And we are using this observable collection because we will need it later for use in our user interface. The user interface will be part of a different video. We will not go in detail to it now, but we will need it later. So that's why I'm already using this observable collection. But for the generation part, a list would also do fine. Or some other way of storing it, an array would also work. And one thing to notice here is that I added this attribute, JSON ignore and JSON property. These properties are important, or these attributes are important because they define how these properties that we're selecting, that we're creating, this FlyingSaw, observable collection, how they are being stored. And the default method of saving your projects is to use JSON data format. And the modular application creator already comes with, let's say, a way of storing it on its own. And you do not need to do much for that. Only you have to kind of give it some instructions on what to store. And this will be important. I will not go too deep into this topic now. I would say this is also part of a different video. Just notice that if you're doing structures like this, where you have a private list and a public list that basically just returns this private field, this is, I think, a good way of dealing with these properties, because you do not want to give public access for any part of the program to change these FlyingSaws. They are very important for this module. There should not be any changes to it that you do not want to do. So you wanted to keep it partially private. So at least we do not have a setter. You can see we only have a get. And the get is required because later on we would like to use it in our UI, and therefore we need to access it. So that's why we need like a public get, but we do not need a setter. So we could also make a private set function, but I always like it a little better this way, although you can also do it different. But this way I have the feeling it's better structured. So we have this private property, which is, for example, being accessed or can be accessed only by the module, but is not being accessed from outside. And we have this public, which only returns as this private property. So we can use that later for the UI. And what we do is we say the JSON property attribute, which defines that this property is going to be saved by in this JSON file that's being created to save your project. So this will be saved. And with the JSON ignore, we say this is not being saved. And that's quite important because you normally want to have like the plain fields being saved. A part of it, why this is very useful is that you could also have, for example, a setter here, like something like this, set, and then you have like FlyingSaw equals value, like a typical setter, and then say I do have here, I want to store this property, and that's totally possible. And when you load your module, then this will be loaded, but everything that happens in this setter will also be called. So there might be situations where in your setter you do some validations or some extra functions that are required for whatever purpose. And they would be called then on loading of the module. And this can create some very nasty situations, because on loading, you're not sure if every object in your module is already there. It's like a loading order. And if you want to access something that's not being loaded yet in this setter, then you run into an error. So that's why I would always recommend saving, like using this JSON property for private properties that do not have a setter, that cannot call other functions when they are being stored or when they're being written. That just saves you some trouble on these issues that you can have when loading an existing module. We will go into detail more with this. I will explain it in more detail. Just for now, as my recommendation, take it that this JSON property should go for the private properties, and JSON ignore for the public ones, so that the program doesn't even try to save this public field. So now that we have it, that we can store our flying saws, we need actually a function, of course, to create those flying saws. So in the first step, we need to initialize our flying saws list. So for that, we are going into our constructor. I would always suggest to do that within the constructor. So I will add that here. Basically just saying it's a new observable collection. I think it's pretty basic so far. And in the next step, we need to define a function to create a new flying saw. So I will do that also in my module. In order to structure it a little bit better, I would probably just add it for now right here underneath the GenerateTiaPortal function. So this function is also, I think, very basic. You can set a name for the flying saw. Default name would be flying saw. And then it creates, here we can also add, for example, an initialization if it hasn't already been done. It's always good to make sure that it's initialized. And then we just say a new flying saw is being created by creating the view model and adding it to our existing observable collection. So, and this function is only needs to be called, and also there I would suggest calling it in a constructor. So right next to our initialization, we just add this function here. Create new flying saw, don't need any input, it's only one flying saw. And that's it. Now we have created our flying saw. Now we've got a flying saw created on the calling of the constructor. That means when we start our module, or when we add our module to our project within the modular application creator, it will create a flying saw there with all the components that this flying saw has. So we defined that in the last session. This will have an infeed axis and a cutting axis. And both of these cutting axis and infeed axis will have an already existing technological object. In this case, it's called technological object info. I think I was explaining it briefly before. This stores all the information required to create an actual technological object within your TiaPortal project. But to really create it, we need to make some small additions to our module. We need to make these additions, of course, in the GenerateTiaPortal function. So we want to do this during generation, so we have to go into the build phase for the technological objects. At this point, either of both is totally fine. Here I would suggest, because there will be a lot of functions for the generation that we need to add, to add some kind of class that stores all those functions for your generation. You can do it however you like. I like to, for example, add a new folder here in your project called generation, and then add a new class into it. Which I would call here generation controller. And this is where we would store all the relevant, maybe, for example, constants, functions, and everything that we need for the generation. So that's why I call it generation controller. Add it to my project. And here and then all the functions required for the generation will be found here. Make it public because it needs to be publicly accessed. And then I can start adding functions to it. So for generating the technological objects, the function is actually quite short and simple. Show you quickly. So I would add this function create TOs. You can name it however you like. I would need to add my PLC device to it. So I can actually generate those to my PLC device. And also, in this case, I'm giving it my module, because that would be also required for the generation of these technological objects. So the syntax is that I'm selecting all the TO infos from these provided technological objects. This class is part of my module, or not this class, it's actually a collection. And we have been working with this before. So if I go to it, sorry, wrong way, I think we added it probably here in this access base view model. So we were adding our technological objects here, and yeah, here we did it. Here we said, okay, to the provided technological objects collection, we are adding the technological object. So this function is called whenever you create a new access base view model, and this is the base for our cutting axis and the infeed axis. So the steps are basically creating this FlyingSaw that we did in the previous step. The FlyingSaw will create its subcomponents. So this would be the cutting axis and the infeed axis. And when each of these both is created, they create their own technological object info, this class, and add it to our list. So to this collection. So in this collection, we would be able to find these technological object infos. So that's why we are just going through this collection. We could also do it in a different way. For example, we could say, we could maybe make a collection of our own and call it all TO infos with module.FlyingSaw. We could do something like, it's possible. In our case, we only have one, so we take the first and say cutting axis dot. Sorry, we need to create a collection before, or at least. So make it, for example, make it a list here. List technological object info. Then we add to it let's go with the first in this case, cutting axis dot technological object. So we could do this now for our cutting axis. We could do the same for infeed axis, and then use this to go for this for each instruction. So we can say all TO infos, and it would also work the same. So really, it's the same concept, just it's a bit more, let's say, shorter and maybe simpler to do it with this provided technological objects collection. So I will go with this one. It will give me all my TO infos that I get from this collection, and it will then, in the next step, generate the technological object for this. And this will be done in the TiaPortal project. So after this instruction is done, you will have a technological object in this in your project with the given information, like name and technological object type and all the parameters required. So yeah, that's basically everything that needs to be done at this point. And then it would create the TOs. And of course, we need to create, we need to call this create TO function within our generation logic. And in the generation logic, we will call this create TOs function within the build phase. And for that, I prefer to take the first build phase, which is up here. But it would also be possible to do it in the second build phase. That can also depend on your use case. But basically, in the first build phase, you should have all the required information and all required objects at hand. So here, this is perfectly possible to do. So that's what we do. We set the create TOs function. We give it our PLC device and our module, which is this. And here we go. To give a short summary, what we have achieved so far in this session, we have created a TiaPortal library within our Visual Studio project. So we have created all those classes that you can find in this folder. And those classes that are created from the TiaPortal library, they will be used to create your TiaPortal library in your resulting TiaPortal project. So if you press the generate button with your module, then you will for sure get your TiaPortal library generated. And additionally, we created the technological objects. For that, we have created a default FlyingSaw. Like this is one FlyingSaw with its sub-elements. So when creating these technological objects, you would expect two technological objects within your TiaPortal project, which would be the cutting axis and the infeed axis. And these will be the elements that are currently created if we press the generate button at this point. The next thing we would like to create is a data block. This data block is going to look like this, like the one that I just opened in my TiaPortal. It will have a variable for each flying saw that will be created, which stores some general information and can be used for config or control options within your PLC program. So here it's just, we just want to create some arbitrary global data block similar to this one, which basically contains the information for each flying saw that we have created within our module UI. And in order to achieve this, we go back into our Visual Studio project, obviously, and go into the generation controller. And here I will add a function to achieve this generation of this data block. So this function will be called GenerateTiaPortal, or however you want to call it. And it will basically need to get the parameter PLC device and the module. And in order to create this data block that we want to have, we first need a name. So here I like to use functions which can define the name of my data block in this case. So I create this function here and say, okay, this global DB name. Here in this case, it gets the module name. This is the module instance name that you chose when adding a module to the modular application creator. And after that, a dot global DB. So similar like in our project, here we have this getting started is the module name dot global DB. This way we have rather unique names. So just calling it global DB might be problematic if other blocks might also be called global DB. So that's why it's always important to have some kind of unique identifier for your module related properties or elements like here. So this gives us our the name for our data block. Then we create an XML global DB class. This is a class that we get with the modular application creator. So we can just access it by adding the right using clause. You can see here that I'm using this namespace automation modular application creator.tiaOpenness. So this shows that we are using functions that are being provided by the modular application creator and which help us to get done with our tasks like creating data blocks more easily. And in order to create this data block, we first, of course, have to create this data block class, XML global DB class. And here we can define interfaces. Like here you have, for example, the interface static. That's an enum that also comes from the modular application creator and is basically used to define the static area of such a data block. And of course, this enum contains other scopes as well. So if we have a look into this enum, we can see here we have constants, temps, input, output, statics. And those will be the same for data blocks, for function blocks, for any other blocks that you can create within TiaPortal. And if you've worked with TiaPortal, you probably have seen this input, output, in, out, and so on. So I guess this will sound familiar. For our data block, of course, we only use the static scope because we want to create static variables within this data block. So we create this interface, or we actually get this interface, and then we can work with this interface and add interface parameters to this. So what we do, we go through each FlyingSaw. And for each FlyingSaw, we define this interface parameter. We give it a data type dbhmi underscore fs. That is the data type that we have chosen for this FlyingSaw. And it depends if you have a measuring input or not to add an mi or an l. Like we have these both data type classes. So here's even a distinction whether or not you have a measuring input. At this point, we haven't included this measuring input interface so far. So we always set it to false. But once we are able to include this measuring input interface, which is also part of the library, we could make that dependent on some parameter that is still to be defined in the module. At this point, we just say, okay, it's false. We keep it there for maybe later use. But since it's always false, it will always add this L to my data type name. So in the end, I'm getting this type dbhmi underscore fsl, which I also have in my example here. So the data type name is defined. And then in the next step, I can create this interface parameter. I say, okay, it's called the same as my FlyingSaw. It gets the name of my FlyingSaw. So you can see here, it has this name. In my case, it's just called FlyingSaw, but you can name it, of course, whatever you want. And then we just add this interface parameter to our static interface section. And that's basically it. Now we created this parameter with the given data type. And in the next step, we could, for example, add some more parameters to it. Like, for example, idf param dot remanence, for example. We could set the remanence. And then I get some options, ignore, non-retain, retain, or set in DB. And this is this option for the retain. So you can basically set if it's retain or not. And in similar ways, you can also define the other parameters, which you can in TiaPortal select by clicking those checkboxes. So this is possible to set those values also through your interface parameters. I will keep it with the default. And that's basically it. Now, the next part is a little bit more tricky because we need to create an XML code out of this DataBlock class. This is basically required because in openness, a lot of those adding function blocks, adding data blocks, adding any kind of blocks to your project usually only works through import and export. And import and export have to be done usually with XML files. So this is also what's happening within the modular application creator. And this preparation of these XML files, that is a really, really tricky part because if you want to do it on a generic way by creating functions that will create your XML file, that will be a lot of work. So that's why the modular application creator gives you a possibility to create these XML code and an XML file already with its own functions, and therefore saves you a lot of work. I can tell you that if you were like to spend a couple of days on trying to see what is behind that, try to create those XML files with some program on your own, and you will see what I'm talking about. It's really a lot of work to do it. So it's a very, very nice function that we have in our modular application creator that we can basically say we generate this XML file. This gives us an XDocument class. XDocument, as most of you probably know, is an internal class, in this case from Link, that is being used to handle XML documents. So this way we get an XML let's say, code that we then turn into a direct string. So we get like a plain XML code that you could basically pass into a empty text document and get an XML file. And this is the purpose. We need an XML file in the end to be able to make the import. So we create this XML code as a string here, and this variable block as string will contain that. If you do a debugging session and have a look at it, you will see that this is really plain XML text, and you can instantly copy it into a text file, and it will be working as a normal XML string as you would expect. So this is the one part, and the second part is that we need to define a target group. You probably remember that we were in the beginning of this session creating some extra groups within our tiares file. I will show that quickly to see what we're talking about. Here we had created our module instance folder, and in that we have a DBs folder for global and instance DBs. So this global DB, of course, should go in this DBs and global folder. So this is what we have to select. And this is also what we're going to do by saying here the target group is resource management, module.resource management, and module blocks root group. And with these brackets, we can define the subfolders. So DBs and then global will get us to the right path. So now that we have our block as a string, as a XML string, and we know our group, now it's time to actually generate the block. Here I've created, or I've already prepared a function for this generation. And this generate block function is basically just creating a temporary file on your hard drive and uses this file to import it into your PLC via openness. So first we need to add some using arguments. Here we use this path, this file.io, and here we use the modular application creator help file. And basically, as I said, what we do is first we define which extension do we need, because for SCL files, the .scl function would be necessary. So we can create .scl files, which can also be imported in TiaPortal. Like it's a more native way of importing .scl files for specific cases, or we go with the .xml file extension. In our case, of course, we stick with the XML extension because this is obviously an XML block that has nothing to do with SCL at this point. So that's what we do. We say here our extension will be the .xml, and then we use this path.changeExtension function for first creating a temp file. So we kind of created a temp file on our disk. This will be created in your temp folder. You would be able to find it there if you want to have a look at it. We changed the extension with this function, and then we have the file with this path given. At this point, of course, it will be only a temporary file which does not contain anything. In the next step, we say, okay, we write all of this text. The text is our code, and the code is our block as string, so it's this XML code. We write it into our temporary file. So after this line, we will have a functioning XML file with all the contents for our global DB, including path and like the path of the file, but not the path of the target yet. This will be done in the next step. Here we use the modular application creator openness functions to import a block into the PLC. So this is also a nice function of the modular application creator to make it easy for you to import your blocks. You just add the file path that you want. The target device is like your PLC device that we are passing around already for some time. And here the target container is important. If this is null, it will be added into the root of your project. So that would be then kind of on this this area, then here you would be added here. But if you say, okay, no, I want it in a specific folder, you can give this target folder like we want to have it kind of in this global DB folder. So we are passing this argument, this target container, and then we will get the imported block in this target container. And after we are done, we delete this file because we don't want to have garbage on our hard drive. So we delete the file, and then our hard drive is nice and clean. All the traces of our import are gone, but the block is finally found in the TiaPortal project. Of course, what is left is to call that function, because obviously we just created this function, but so far it's not being used anywhere. So as we always do, we go back into our GenerateTiaPortal routine, and there we will edit. And here I would strongly suggest adding it in the second build phase. This is because in the build phases, as I said, the TiaPortal library that we added will be created. It will be initialized in the init phase, but it will be created and generated into your TiaPortal project within the build phase. And since we use this function, this data type that comes from the library, you probably remember we have this type db HMI FSL. This comes from the library. So if we want to create this global DB, this type has to be already existing, because otherwise we cannot import this DB, because if we try to import this DB before this type exists, we will get an exception that openness cannot import it. Openness can basically only import, or usually can only import DBs which are compilable, which do not contain errors. There are exceptions, so it doesn't hold true for all the cases, but for DBs, it's required that the DB is compilable. So we need to make sure that everything from our library has been generated, and this is basically the first time the case in the second build statement. So in the first build statement, it's not there yet. We can create TOs, but we can, because they do not require any types from our library. Then after the first build phase, the resource management will go into its own build phase. And then after that, we will have the library generated into our TiaPortal project. So in the second build phase, or in the second switch statement for the build phase, then we will be able to access all those types and elements that we have imported from our library.
So here we can call this function generation controller GenerateDB. So here we again add our PLC device and our module, and that's it. So now we will have the global DB generated if we generate this module. Next thing we want to do is create our tag table, or basically we want to add things to our generated tag table. As I told you before, there is a tag table which comes already from the library. I show it here in my example project, which has the final version, so do not be confused. This is how it's supposed to look when we're finished. But basically what happens is that our library contains this tag table, and as I told you, these first tags are already there, so they will be imported from our library. And what we want to do is adding these 4 extra tags. And in order to do that, of course, we go back to our project, we go back to our generation controller, and we add the following function that I have prepared. It lets us generate or add to an existing tag table. And for that, I will go down a little and add this function here. So this is a bit of a, let's say, bigger function. And what it does is that it generates or adds to a tag table. So in my case, it's called generate tag table, but probably a better name might be generate or add to tag table. But yeah, names are not that important. And what I do in the first step is I define my tag table name. So my tag table name is, let's say, CS210 demo case IOs. That's the name of my tag table, as you can see here in my TIA project. And next thing is I need to find this existing table. So in my case, I would like to access a table that's already existing. So what I'm doing for that is I'm calling this function here. Basically, I go in my TIA, my PLC device, which here I will get from, which I have to pass. This has a tag folder, which contains the groups. And here I do the try get group function. And the try get group gives me the group where I expect my tag table to be in. So here in my case, my group that I'm expecting is supposed to be named after my module, because this is the module instance folder. So it's supposed to have the name of my module. So that's why I'm saying, okay, give me the, try to get the group which is named like my module is. I make a typecast to a tag group so I can have the right type. And here in the tags area, I will find tag tables. Do not be confused. Text in this case is relating to tag tables. So I basically say here within this tag tables folder of my PLC, I select with the where statement where the tag table.key, key defines the name, is equal to my table name. So basically I'm searching in this folder for the first tag table that matches my tag table name. And since this is a dictionary, as you can see here, this tag group.tags is a dictionary delegate. So I want the value, which then in the end is a tag table. In case you want to create your own tag table and do not want to use an existing, you can use this statement that's currently commented out. I will comment it in to show it. Basically here you can say, okay, I directly go to the tags folder, similar to how I do it in the lower statement. And I can use this get or create global tag table statement and say, okay, this table name, and then it will check if a global tag table already exists. The thing is just it will only look in this specific folder This is in this case the root folder. So I would not be able to find a tag table here that is in some of the subfolders. That's why I need to use the syntax here to find it in the subfolder. But if I, for example, say I want to create it in this root folder of my tag, the root folder, in case you do not know, is basically this on this level. And if I want to find it here, I could do it with this statement. And this would either give me an existing one or create a new tag table. So I could also go with this if I wanted to use a new tag table. In my case, I want to use an existing one. So I go back to my original statement. I say, okay, find me the tag table where the tag table name is actually the required name that I have given here. In the next step, I'm defining the names of the tags that I want to add. General power, home saw, move in feed axis, enable auto mode cutting. And then if you have a look here, you can see that they have in indices. Like here's an index, 0, 1, and whatever you can add. Basically refers to each of the flying saws. So each flying saw has kind of an index. So I need to increase the index for each tag that I have created. And also I need to give it an address. So also I need to take those points into account. So what I do is I'm setting an address byte and an address bit that I'm starting with. In my case, it's 100.0. And basically, my intention is that I want to increment those address bytes to always have like a valid address range for my tags. How this is being done, I will show you in a minute. But first we go through all our flying saws. In this case, we go with a for loop, not a for each, because here we need this index I that I told you about. So what we do for each tag, we first set the final tag name, basically by adding this index. We add some comment that we would like to add to it, and then we trigger this create tag method. And this create tag method, I will include now. This is going to look like this one that I'm adding here. So you have an existing table that you're adding to it. This is, of course, a table where you want to add your tag to. You have an address byte and an address bit, and tag name, and a comment if you want. And here, the first thing that we want to do is get a proper tag address and at the same time increment it. Because we basically say, okay, we have an address bit and an address byte, but it doesn't already give us the required format to add it. So as you can see here, 100.0 is not sufficient. We also need this percentage sign, and in this case an I, because we have an input variable. So we want to create kind of a string from our address byte and bits. So what this function does is it creates this string and increments address and bit and byte because it's kind of saying, okay, if I'm giving you this, then I know this will be occupied. So I already increment these values. So the next time you use them, they are valid again. So on the first thing it does, as I said, it's creating the string. So basically percentage I and then address byte dot address bit. I think that's quite clear. Then the address bit is being increased by 1. As you can see here, so we have 100.0, 100.1, and so on. And here, as you know, address bits, if you are higher than 7, you have to increment the address byte. So this is what's being done. So it's basically says if the address bit is higher than 7, you increment your address byte 2. And if the address byte is, in this case, 101, it increases the address byte again because the 101 address is already occupied. You can see it here. So Actually, that's not even required because the address byte is. Oh no, because we have it here. Sorry, because here the 101.7 is already occupied. So I was like, okay, let's skip the 101 address byte area. So it would skip the 101 and increment it another time. So from 100 we get to 102, and it would set the address bit to 0. So basically, when we have, for example, 100.7, we increment this address bit, then the address bit would be 8. So this means the address byte would be incremented plus 1, and the address bit is being set to 0 again, and we return the string for our address that is being created. And that's basically all that's being done here. We get the tag address as a string, and we automatically increment the address byte and address bit to the proper area for addresses. So next thing is we have a look for the tag, see if the tag already exists in the existing table by using these brackets and identifying our tag. And if the tag already exists, if it's not null, then we delete it. We could also just change it. I mean, theoretically, it's possible that the tag exists, but it might do something totally different than we want. So we could also just try to change its data type or its comment. But usually, it's easier and sometimes more clean to just delete the tag. So that's basically what's happening here. If the tag already exists, it will be deleted, and then a new tag will be created with the add tag function from the controller tags table. We get the tag name, we set the data type and the tag address. We set a comment. In this case, the command is only visible if you set your tiaPortal to English. You could also add other languages, but have to add the the language key kind of for it. And yeah, that's basically what happens. And then we return the tag in case somebody wants to do something with it. And then we return the tag address, sorry, in case somebody wants to do something with it. So this is basically what's happening for all of those tags. So, and now we have basically done that for not only this general power tag, but we do it for the other tags too. So in this case, those tags are being directly created. Here also no import or anything is necessary because we can directly access this table, and the table can directly be created with openness. So here no import or export is necessary, at least not for you as a user for the modular application creator. So yeah, in this case now we have created our tag table, or basically we changed our tag table, we added new tags to it, we made sure that we have a valid area of address where we are adding those tags, and we made sure that we're adding those tags for all of our FlyingSaws that we have. So even if we add more FlyingSaws, we do not need to change anything here. And last step, you probably know it, we need to add it to our generation routine. So we go back into our generation phases, and here again, where you put it depends a bit on what and where you want to use it. As a rule of thumb, I would argue that you should do it before generating the data blocks. In our case, it wouldn't matter because here we do not have dependencies between the tag table and the data DB. But oftentimes, for example, the data block might be using some arrays with some that's based, or the length of the array might be based on tags. That's quite a common case that happens a lot. So, for example, imagine a case where you have your data block, and for example, here you don't want to have this flying saws as a property for each flying saw, but you want an array of this type. And you say, okay, I have an array which basically goes from what would it be, 0 to, and then you might have some kind of constant or a tag, basically, maybe some tag like number of or FlyingSaw. This is quite a common case. I've seen a couple of times. And in this case, you have this number of FlyingSaw property, and this oftentimes comes from a TagTable. So in order to create this global DB with such an array, you would need to have this tag actually existing. So that's why that's usually one of the major cases where it's very important to have the TagTable generated before the global DBs. So that's why I would always suggest to do it this way. It's usually, like if you have dependencies, it's usually this way. It's not the other way around. So usually the global DB depends on the TagTable and not the other way around. So TagTables are usually one of the first things you want to generate. Like for me, it's been good practice to first generate technological objects, as we do here in the first build phase. You can also do it in the second, but usually create them before everything else, because many function blocks usually have references to the TOs, so they have to be created. And next thing would be the tag tables, because the tag tables are basically also depend usually on the library, if at all. And then you can create the global data blocks. That's, I would say, is a good way of finding your own order of creating those. But of course, in each use case, it could also be different. That's just some idea that might help you, but of course, feel free to change it or to do it in your own way if you feel it's more suitable for your use case. In the next step, we would like to create our calls for the OB1. And this basically is an example to create blocks or to create calls or code into any of the OBs that exists. So the basic structure that we want to create, I want to show you, is the OB1. In our case, before it was empty, and after the generation, we want to add some code. In this case here, the call for this FC with calls for OB1. The OB1 doesn't need to be empty. It can also contain already some content, but we would not delete this. We would just add our own call, basically adding it underneath all the existing networks. So in order to achieve this, we will need to create this FC first. You can already write into the OB1 directly if you want. Like you would not need this extra block just for functional reasons. But I like it better because it's a more structured way. So I would like to show you this approach, basically creating this block first and then just adding the call here. So this keeps your OB1, let's say, nice and clean and easy to read. But of course, you could also directly generate code or calls into the OB1. So here I will show you the approach that I prefer with having this extra FC that is being called. And within the FC, you can see, for example, here that we have some regions. These regions, they have different calls. We have, as you can see, some basic calls where just some parameters are being set. Here, in this case, we even use the tags that we have been generated in the last step. And then we have some call for an existing functions from our library. And you can see here that this inst basic control FlyingSaw. If you hover over it, where is it? Here you can see it's the basic control saw block from our library that we imported. So we want to create an instance DB for this, call this instance DB with the given parameters that we have added here. So this is our task in the next step. And for that, we go back to our generation controller. And here we need a couple more steps. So this is going to be, let's say a little bit more complicated than the steps before. But also I show you the way and you will probably see it's not that difficult. So first, again, I'm adding my function to generate my OB1. I call it generate OB1. Again, it gets to the PLC device and our module, because usually we need both of those to obtain all the required information. And next thing is we define an OB block number. This is important to identify the block, because OB1, of course, always has the number 1. And all the other system blocks, like pre-interpolator or others, they all have fixed numbers. So it's important to give those numbers here, so those can be identified. Here, the name is usually main. So also adding this to it is required, like getting the right name. But usually the identification happens over the block number. And here, as a secondary type, you set it to program cycle, because that is the type of the OB1. You will be able to find that information probably from the TiaPortal project, I think. Yeah, here, like the event class program cycle. This is basically what you have to add here. So it's possible to identify it. Here might be important that this, how you see it here, it's not written how it is written in openness. So you would need to have the identification from openness, which you could, for example, obtain by looking at this block via the openness explorer. That would be one option to look at it. But basically for the OB1, there's always this program cycle. So you can just use it, and I think this is the most used block anyway. So what we create is we create an XML OB similar to the global DB that we had before. This is a class from the modular application creator. The base class of this is the XML logical block, which is just the how is it, general class for those XML blocks. So we create this XML OB. We give it the block number as an attribute. With the block auto number, you can, I think for the OBs, it's always turned off anyway, so this attribute doesn't even matter. If you set it to null, nothing will be done with it. And I think this is okay. Then in the next step, like after creating this class for our OB, it's important to generate our FC with the calls, the one that I showed you. So we have this function to create this block, and of course determine the name of this FC. Then the next step will be to add this FC, like a call to this FC into our OB class. Do not mix that up with the OB itself, because here in the first step, we are working with data classes. So we're not working with the openness or with the TiaPortal elements directly. This basically will be done with an import and in the last step. And before that, we need to set up all the properties and contents of this class that we're dealing with. So here, as I said, we generate this FC. This will also be done with openness, with an openness import, like just generating this FC. Then we create a call to this FC in our openness class for the OB1. And then in the next step, we will import our class into the TiaPortal project, which will then merge the contents of our OB that we create with the existing OB in the TiaPortal project. Because as I said, it's important to remember that we do not want to override contents of this OB. So whatever might be already there in this OB1, we do not want to override it. We just want to add our content to it. And this is exactly what's being done in this case. So we create a class for our, let's say, artificial OB that where we add all the calls and whatever we need. And then in this case, we import it in the TiaPortal project and kind of merge it with the existing OB1. Let's start with the generation of the FC as the first step. So in order to that, I will add some code that I prepared for this. So here we go. So in the first step, we are going to use some template. This is a very let's say, basic function that can help you out in a lot of cases when creating, let's say, complex or big calls for functions, for example, as we have it here. Of course, you can create this block all by yourself by creating a string. That's perfectly possible. But oftentimes, when you know this is a very static call, most of the parameters might not change. It's easier to actually go with a template. So what I do for this is to create my own template, and this is being done like you can create the template. Basically, you can create it wherever you like. I would prefer calling it in the template and tier imports folder because there's yeah all your resources that you need for the generation. So it's kind of fits in there, but of course you can do it a different place too. So here I create a new folder. I call it additional resources. So, and in this folder, I'm creating a new item. Basically, an empty text file is what I require. And yeah, any file, any text file is fine for this matter. I'll just create any. And here I will create, or actually I will create two files. Because the basic concept that I like to use is to create a template for a general SCL function call. This SCL function call has a specific structure that you can, for example, see if you export a SCL block from your TiaPortal file in the SCL format. Then you get something that will look like this. So there's like specific structure here. This is the very basic structure for basically an empty function call. There can be more properties to it, but for our case, we just want to create an FC, which basically has just some content, but we do not have any properties here, as you can see. So this is fine for our case. And what we have is like here you have like a kind of let's say an interface, a header, or however you want to call it. That's important for later import. And here you have some content. So you have a begin and end function, and in between is basically all your SCL content that you would like to import. So this file will be used for all SCL calls that we might want to create. In our case, here we only create one for the OB1. But for example, if you wanted to create the same concept for startup or for pre-interpolator, you can use this template again. So I would call it's quite a general template. And here you can also see we have some placeholder for the FC name. So this also needs to be filled out before the import. And the name that we will give it will be template. Hang on, let's see. What was the name? Template SCL FC. This is what we are calling it. So this is our template number one. This is used to generate a general or to create the structure for a general SCL call. And for the specific call, we will use the next block that the next file that I prepared. And this will contain the function block for our call, the function call for our FlyingSaw. And here you can see I copied in the content. And if you look at it, you can probably see that it very much resembles what we have created in our TiaPortal, or what we want to create in our TiaPortal project. And you can see that many of the entries probably will always stay the same. But of course, you have to make, let's say, the property names match to the property names that we're actually generating. So specifically, we have a name for the for example, for the leading axis and for the flying saw axis. In this case, like this would be cutting and infeed axis. In our case, they have a specific name. So of course, this name needs to be used from our data model. Then we have access to our global DB. So we're using the global DB and need to make a reference to the flying saw that we want to use. So you probably remember in our global DB, we create the structure for each flying saw. So we also have to use the proper names that we used from our global DB. So this is kind of the things that are dynamic. So these have to kind of be changed depending on what settings you have set up in your UI or in your data model. So in order to realize it, we use placeholders. So we have one placeholder here for the instance name. I like to mark those placeholders, for example, with these kind of specific brackets that you can see here, or as you've seen in the other case with these, how do you call it? These, yeah, these symbols that you can see. Basically, just like you can also use any other kind of placeholders, any other symbols. Just make sure that there's no mixing up with other names, for example. Like if you give it a if you leave away these symbols, for example, and you give it a name that might come up in one of those properties that you don't want to change, that could cause some trouble. Because what we do in the end, we use some string functions where we just replace a certain string with another string. So we will replace this placeholder string with whatever flying saw name we have. And if this placeholder by accident has a similar name like this, like basic control or input or whatever, then you would also replace this part of the template that you do not want to replace. So that's why I would always recommend using some kind of symbols that are, let's say, unique in identifying that this is actually a placeholder. But yeah, of course, it's up to you to decide how you deal with that. And the nice thing that we can do here is actually creating placeholders, like one placeholder, and use it again and again. Like you can see, this global DB name, this is being used a lot. So of course we use the same placeholder for that. Same goes for the flying saw name. So this way we have like one placeholder that we use in many places, but we can use like do the replacing of the placeholder only once in our program text, which I will show you in a minute. The name for this, I will call it this template call basic control, because this is the name of the block. Basic control is the name of the block that we're calling here. Or the basic control saw, it's the name. So yeah, this is just for us internally to identify it, but yeah, you feel free to name it however you feel like. So in order to get done with our FC our function call, we want to use this template, of course. So what we will do is we have a function to get this additional resource. I will add it down here. It's called get content additional resource, but yeah, you can name it however you want. Here it's important to have the right. Oh, no, sorry, I forgot a thing. In order to make this work, you need to first set the property for this these templates that we created in the properties tab. Like here you have this build action, and here it's very important to set it to embedded resource in order to access it. This is very, very important. So if you have the problem that your code isn't able to access this, most of the cases you haven't set this property. So do not forget that in any case. So going back to our generation controller. So what we need to do now is to have this get this access to this additional resource. I'm using this function by basically getting my assembly, and from my assembly I can get this resource stream by setting up the right namespace. So here the namespace Siemens.modular application creator. Let's see, is it our actual namespace? No, actually our namespace here is a bit different, sorry. So actually our namespace would probably look more like this. When getting started .tia imports. So the namespace for your program you can find here if you get to the properties page. And here you can set the assembly name and the default namespace. So we're going with the assembly name, not the namespace, sorry. So this is important. So whatever you set up here in the in the assembly name is what you need for the path of your assembly. No, sorry, I'm wrong. It's actually the namespace that's important. You're going for the namespace. So here the basic namespace is in my case getting started. So this will make my give me this path to my additional resources. So getting started .tia imports additional resources. So here I'm getting started tia imports additional resources. I could change that, like I would do it just to demonstrate how it could also be. I could, for example, say something like, let's say, user x dot my projects dot getting started, because maybe I want to have some kind of, let's say, default namespace for my projects. Maybe I create a lot of projects or modules or whatever and need kind of default namespaces. And if I'm setting this up and creating new classes, they will always get this new namespace, but my existing classes will not. So if I, for example, have a look in my my getting started EM, you can see that the namespace is still the same. But if I'm creating a new class, I will delete it in a minute, so don't worry. If I create a new class, then you can see that the namespace has changed. So if you want to change your namespace, make sure that maybe do it in the beginning. So otherwise you might have to adjust the namespace in your existing classes. And if I'm changing this namespace like I do now, I show you for a minute. My new namespace is this. Then I would also need to change the function for getting this resource into my new namespace. So yeah, this is important to access your additional resources, your embedded resources. They need to be accessed with the right namespace. I go back to my original namespace that I had with the just getting started as a namespace. But just keep in mind that this is important, and it could also cause, let's say, some trouble for you. So now, after a short excursion to namespaces in our project, let's go back. So we want to get these additional resources that we are storing in this additional resources folder. So we have this function in order to access our additional resources. Now we can go back to the beginning of our function. So what we do is, in this function, we want to create an FC code string that contains this, let's say, header information that I was showing you from this SCL FC template. And of course, the content that our FC actually contains. So the content will be everything that you can see here from line 1 till line 45. This is our content, and we will generate it in a clear string format. So first of all, of course, we get this template SCL. So we have like kind of the template, and now we only need to define the FC content and of course the name of this block. So we replace this FC name placeholder from our template. Show it again. This is basically just this here, this that you can see. So we replace it with the actual FC name. Here also we say that we don't have a measuring input, but we already create some code in case we have a measuring input. As I said, so far we haven't implemented any function there, but in case we ever have, then we only need to give this property some function behind it, and then the code would automatically react to it. And yeah, so what we need to define, like as I said, we have the template for our basic control saw function. This is the template we created, which has a lot of placeholders. So our purpose is actually just reload this resource, then we get all this code, and then we just replace all those placeholders. That's basically it. And the whole code is to determine what are the values for those placeholders. Also, we need to define a target group where we want to include it. So here we have this DBs, an instance group. It's totally the same like we had it with the global DBs, or like the same principle, but instead of the global DBs folder, we added to the instance DBs folder. Here I will show it quickly. Here we have this getting started, we have DBs, and if you look at it, we have the global and instance DBs. And in the global DB folder, we'll find our global DB. And in the instance DB folder, we'll find our instance DB later. So that's what we say. We say here, this is our target group. We define it as we did. Then we get the resource for our basic control template, as I have shown you. And then the fun begins. So in my case, I feel more confident with creating lists of snippets for different regions, for example. But of course, you can also create it as one string or in any format that you like. My reason why I like to have these lists for the strings is to have a better control over the order of those. Like here you have a IO to DB snippets and a basic control snippets list. So basically, it's probably easy to understand. The snippets, the first list is snippets for this region, and the second is for this region. And the reason why I have separate lists is that maybe if you want to change the order, for example, if you say, okay, right now we have this IO values before calling this basic control, that's what we need. But maybe in the future you say, okay, for some reason I need to change that. I need to have this snippets or this code blocks before the others. That can become difficult if you're working, for example, with one string where you just add all the functions. So for me, I found it easier to actually create lists of strings, or you can also create separate strings for these regions. And then in the end, you only merge them together. And then you have an easy time in changing the order of those. So that's basically done in the next step, or in the next step. So I will skip this middle part for a moment. This is basically where these lists are being filled. And after these lists are being filled, we have this lower part. In the lower part, like we have all the code for the lists already existing. So basically this IO to DB snippets list would have these strings. So they are all there. That's basically our program code. And what's missing is still the region and this make generation label. This is being done in the function that I will show later. So there a region is added and a generation label. That's also what this function says. And then I will add them to my all snippets list. Like all snippets is kind of the resulting the resulting strings that will be generated. And here I'm saying, okay, I have the IO to DB snippets. They get a region and generation label. Then the basing control snippets the same. And then they will be added to the all snippets list, which basically defines in which order it is. So now if I want to change the order of my program code, if I say, okay, this IO to DB snippets, this first region, I want it to be called after the second region. I want to switch the positions of those both regions. It would be very easy now with my current concept. I basically just add them later. I add them to the all snippets list later. I did these steps, and now after generation, both lists would have switched in their positions. So you can see this would be very easy to do, to change the order. If I would have like only one list where all my snippets go, or maybe a fixed string, then that would be a very big problem in changing the order, because I would have to go in this middle part where the lists are filled and make, let's say some bigger changes that might be difficult to really understand. So that's why I always like to go with those lists for each region, for each area. How many lists you need can very much depend on your use case, but I would argue it's always better to have more than less. At least if you expect that some changes might be required in the future. So let's get to the first part of filling those lists. As I said, these IO2DB snippets, they will contain my the first region of my function block, this part, and the other snippet list will contain this call. So here for my first part, for this IO2DB snippets, I will just create strings that do what is supposed to be done. I find my FlyingSaw for the given index. I go through all of my FlyingSaws. I find the FlyingSaw for my index. I have determined the global DB name with my get global DB name function that I was introducing before. And here you can see why it comes in very handy, because if I would define this name in the function itself, then it might be difficult. So I want to have some kind of public function, or maybe it can be a constant or whatever, that they can access throughout my program, and always be able to get this global DB name, because I need it in many places of my generation logic. And then I go here, I say, okay, my FlyingSaw that I'm currently looking at is the one with the index I. And then I create this first snippets, which is here you can see this is some, how you call this, semicolon signs, basically here to define that we're talking about names. So my global DB has this name, which contains a point. And if I'm not using these signs, then TiaPortal will not understand that this whole thing is one name. It will try to find something that's called getting started with the property global_db, like getting started.global_db, and not understand that this is the whole name. So that's why it's always important to have those signs when you're dealing with names of DBs or technological objects or even tags. So I would always recommend that. So here we have the global DB name, this, as I shown you, then dot FlyingSaw name. The FlyingSaw name might be able to contain a point as well, a dot. So we also want to have it in those signs. And then the rest is quite static text, basic power input, general power, and then here we have the index. So we are able to access our tag. We do this for the home, XXOR, the power, the move leading. And if we had the measuring input, we would also have this enable auto mode cutting added to it. And yeah, that's basically all that we will have in these IO2DB snippets at this point for my first FlyingSaw. I think this is pretty straightforward and not so difficult. It's a bit more tricky when we come to the other part, which is the call of this function block. Because first of all, we need to create an instance DB for this function block. And we say in the first step, we need to find like the base for this instance DB. And the base we'll find in our resource management. So what we do is we want to get our master copy for this function block. And this is what we do. We'll go to the resource management, and here we have already the master copy for this basic control saw as its own class and as a property of our resource management. So we can directly go into this and say, okay, we take this as our master copy. And the next steps here, I'm defining the names for the TOs that will be used for the placeholder. They are not important at this point yet, so I could actually add them a bit lower to show you a bit better what we're dealing with. So basically, we have here the master copy that we get from our resource management. We define an instance name for this data instance DB. And this is important to have it unique. Because if you give it the same name as an existing one, it will just overwrite the existing one. And this is something you probably don't want. So that's why it's usually recommended to add some kind of dynamic, let's call it dynamic part of the name. In this case, I add the name of my flying saw because I assume that all my flying saws have unique names. So no name can be there twice. So if I'm adding this name to my instance DB name, I would assume that this is a unique name within TiaPortal and it will not be there already. So here I'm having my module name dot inst basic control underscore and the name of my flying saw. And this is what you can find in your resulting TiaPortal project. So here we have that getting started dot inst basic control underscore flying saw. This is the instance DB that we want to create. So the next step, we actually do the creation. This is then also happening in TiaPortal. Like here, when you do this, it will be directly created and imported in your TiaPortal project. For that, you normally use the function from your resource management, which is module.resourcemanagement.create instance db. And then you have to give it a master copy based on which this instance DB is supposed to be created. That's what I said we get from our resource management after adding our library to the .tiares file like we did in the beginning. We define an instance name and we define an instance DB target group. That's what we did before. I was explaining this already. We want to go for this instance folder and we have to say, okay, in this target group, we want to go in the blocks folder because we're creating blocks. That's important to add in this case. So yeah, so we are sure that this is the right place to add it. And then after this step, our instance DB will be created and will exist in our TiaPortal project. So next is we actually need to call or write a call for this function block. As I said, we use this template. This template already has most of the important properties and let's say elements that we need. And we only need to replace all the placeholders. So it's important to have the right spelling for those because this is case sensitive. And if you, for example, forget that, let's say this A is an uppercase, that can end up quite badly. You will not be able to get a successful generation because it will say that it, for example, it will not be able to replace this placeholder. And when you have the placeholder in the code that you want to import in your TiaPortal project, TiaPortal will give you compiling errors. So that's important. That's one of the most common mistakes, to mix up this upper and lower case, maybe have a error in your spelling. So make sure that you write them properly and in the right way. So the placeholders that we have is the instance name. The instance name we have already defined. So we can just replace it. Can just use the same as we have for our instance DB. We need to use the same. Of course, I think that goes without saying. Then we have the infeed access TO name. So this is something we define here. Again, we need to make sure that TiaPortal recognizes it as a name because there might be points or something. So we need to get it in a format like this, where we actually have those symbols again, where we can see where TiaPortal can understand it's a name. It's not. The point, for example, is not to show that there's some kind of property. No, this is a full name, and TiaPortal needs to realize that. So that's why it's important to add those symbols in the beginning and in the end, and then we can just use the name of our technological object, access it with our data model, infeed access, like FlyingSaw.infeed access technological object.name. I think this is pretty straightforward. Same goes for the cutting axis and for the actual flying saw that we have. And now we can do the replacement. So we say we have this basic controlled snippet that we get. This is the template that we created. And then we do the replace function, like the normal string replacement. And we say replace this placeholder with this value and so on. And yeah, this way we are able to replace all of those placeholders. And you can see, since we're using those placeholders, there's only 5 of them to replace. It's actually, I think, quite easy to see. And here, in the next step, this is basically to add an extra blank line in case of that there's more than one flying saw. Because what you basically want is that after you're done with one call, you do not want the next call to start already here. You do not want something like getting started, blah, something. You want it to actually start in the next line. So this is a bit. So here you do not want to have some call right here, starting after this semicolon, but you want it to start one line later. So that's why we say, okay, if there's more than one flying saw, we will add a blank space after each. After in the current basic control snippets, like we add this this blank line before our the code that we have, and then we add this code that we created with all the replacements and everything. We add this to our basic control snippets. So basically, this is what we've done. We are adding into this IO to DB snippets. We are adding this functions for the using this tags and setting this DB entries to this tags that we're getting probably from outside. I mean, they're input tags, so they're probably giving us some information from the outside through the connections, through the PLC connections, and we want to use them in our global DB. And then we have this basic control snippets for the actual function call that's being called in the OB1 for each of our flying saws. So this is what's happening in this for loop. So here as I said, we are filling those basic control snippets. And after that, we are done with creating these contents that you would find within the region. So this part and this part would then be already created. Now, as I said, what we need to add is those regions. And in order to create that, I've been creating those functions, add region and generation label to snippet list is what I call it. You can just copy them from this getting started because I think they come in quite handy. So now I'm back. And you can basically use them in all of your modular application creator equipment modules. And here it's a bit of a, let's say, it's not very complicated, but it's maybe not so easy to understand what's actually happening. You have a line prefix, which is basically saying if it's a comment or not, because sometimes you want it to be a comment, sometimes you don't. For example, if you want to create a region that is not active yet, maybe because you're missing something and it's not compilable, but you want to create it already so the user can just remove the comment and then already has it once the criteria are met. Maybe, for example, you do not have certain parts of the certain technological objects or properties are not available after generation, but maybe the user can easily add them manually later in his TiaPortal project. And then he just needs to remove the comment, and then he has his functioning region. So it could happen that you want this region to be commented out. So this is done with this is comment property. Then you want to have a generation label. And for that, there's also a function that I would add here. So this is basically looking like this. This is the generation label that we basically use within Siemens for our modular application creator projects to identify which parts of the program have been created by the modular application creator. So this is how we create this. So you have here this Mac label, and then I have an instance name, a calling group name, and module ID and the GUID. Important here is really the GUID because this is unique for your module. So then your module application creator can understand from which module this part has been created. And here you can see how this might look like. So here you have like this Mac label. It's coming from the getting started module. So this is the instance name of my getting started module. The calling group name is basically, in this case, the name of this region. But yeah, can also be some other kind of identifier. And in the next line, you have the module ID. So this is the whole generation label. So this is being created with this function. And here for our region and generation label, we have this generation label plus line prefix, which then might or might not be a comment, then the region, then again the generation label unit info is called here. That's basically the name of the region in this case. Next step is that you have the last label. This is basically what's happening in the end. I like to make 2 empty lines just to kind of give a division, showing that like unclocking the code a little. The line prefix, as I said, might or might not be comment, and then an end region and another 2 empty lines, just so you have like a clean code with a couple of dividing spaces. But yeah, can be done as you want. And the result is a list of strings, basically the first label, then you have all your snippets, like your code that you have, and the finishing label. And this is basically what you get. You get a snippet list that will contain all this part, including the region. And this comes in pretty handy because usually clustering your code in regions is at least good for the looks. So you can get a better overview of it. It looks cleaner and might also be easier to make changes later on by just moving regions. But it's not a must. Like you can also do it however you like. But this is a suggestion from my side. So what I do is here I'm adding this region and generation label to my snippet list. And then I add it to my all snippets list. This will contain all the snippets in the right order. And in the last, or in one of the last steps, I'm creating let's say a one string from this snippet list. And as you can see here, it's basically just adding snippet to snippet. It's just creating one block of code of string code from this list of single strings. And almost in the end, I will use this FC code string. This is what I created in the beginning, where I said, okay, this template SCL FC was used, which gives me my basic structure for an SCL code. And here I have to add my FC content. So this is what I'm doing here. I'm replacing this FC content placeholder with my actual FC code. Then in the next step, I'm selecting a target group. I say here target group is my module blocks root group and my FC's root group. This is one that I created in the TRS file. I'll show it again so you know what I'm talking about. This is the FC's group that I created earlier. So this is where I want my FC's to get into. And then I have this generate block function. This is again the same function as we had before. We have created the DB with this function You can here see it here. And in our case now, we are creating an SCL file. So what we do is we call this generate block, but this time we set the isCL property, we leave it to true. That's like the default case. And that's the only difference to calling it in our DB. So the extension now will be a .scl. This is because, as I showed you, this structure here is not XML structure, but a structure specific for SCL blocks, which makes it easier to implement or to import SCL blocks. You could do it also with an XML structure, but it's much more difficult to create an XML structure and much less readable to create it in XML if you have an SCL structure that you want to create an XML file from. So I would always recommend using this .scl ending and the specific import for that is shown here. The function is the same. We'll create a temporary file, adding our code into the file, import the file to the PLC, and then delete the file. So everything as we have done it already. So the next step is that we not only want to create this FC with calls, which we now have done, we also want to add this FC with calls, or we want to add a call to this into our existing OB. So for that, as I said, we have this function add FC call to OB. And now we have a look at this specific function that's a bit more simple now. I will just maybe add it directly here. So this function, basically you see it gets a lot of variables. It gets the FC name that we want to add. Like this is the name of our FC that we created. The OB class that we were creating before in the upper part. The generation label that you want for that. This will be the generation label that you can see in the main. So you have here this generation label, which also contains the module ID. It's basically similar to what I've shown you before. And the PLC device and a module, because they are always required for some information. And here we basically create a new block network. This is a new class that we haven't seen before. This is also a class from the modular application creator. It lets you create a network of for calling those blocks. This basically this will be this network too in this case. So we create a class for this network. We have the FC code. So what we do is the code that we have in SCL in this case, we have again here determining saying, okay, this is a name. So we have this symbol again. You can see. And then we say, okay, the name of the FC. And then we have an open and closed bracket. So basically, this is basically how you would call this block in SCL. And now you're wondering, okay, but what if I do not want to have SCL? Because here in my example, it's obviously not SCL, it's called in fubcop. And here's another nice thing that you can do with the modular application creator is to parse it from an SCL call and create an arbitrary function call out of it. So basically what we do, we create an SCL function call that we then parse and kind of turn it into a FBD call, like in our case. And this is quite powerful because it saves you a lot of work, and because doing this on your own might be very difficult to do. So what it does, you can just basically copy this function. You have this parser. This is also a function from the modular application creator. You say parse SCL call, then you take this SCL call string. You give the PLC, you define block type, and here for the grouping, I think for normal case you don't need any grouping. And then you get a network resource or network class out of it. In this case, we can use it as block network and um, basically use the blocks and yeah, like let's with the first function, we get like the first block. It usually contains only one block, so in this case, it's more than enough. But this way we can parse, as I said, a single SCL call and have a SCL call turn into a block call actually. And this way we have an arbitrary block call, and this can later be transferred into SCL call, in the FBD call, or AVL call. And yeah, that's basically what we do. We parse it into a single SCL call. Yeah, use this way, and then we have this our network where we add to the blocks add this FC call. We can give it a generation label. You can see here, that's what I've shown you before. That's where this generation label gets into, and module name and module ID. This will be what's written above this network. This is purely optional. So and then you add it into the OB network. You add this network that we just created. So what we did, we created a new network. This will be network 2. We added this call. We passed a SCL call into a arbitrary function call that we then can add into a network .blocks .add, and then add this FC call. And you could add more. Like if you have more calls that you would like to add, you can do it in a similar way and add more calls. And then you add this network to our existing OB class. Here it's important, we haven't done anything in the tiaPortal yet. So this is just our class that at this point only exists in the modular application creator. And in order to get it into the tiaPortal, that's where the next function comes in. The function I've named it at codeblock to OB. So this function will be a little bit more complicated, but I will try my best to explain it to you. So, and this function is also one of the functions that you could basically use in every of your projects. Like it's possible to just copy it into your project and use it again, because it's a very general function that you can use in many, basically in all the cases where you are working with things like importing into existing OBs, creating new OBs. And what it does is that you have this XML logical block. This is our OB data class that we have created, where we added a function call to our FC. And at this point, as I said, this is just the data model that currently exists in our current OB, in our current module. We give the OB number to say, okay, in which OB do you want it? And then the program runs through this code that I'm explaining. So we first see, is there an existing OB? Is there an OB that exists already that we might want to parse our code into? And so here we have this try catch, where it basically checks, can I find a block with the existing number? And if the block is not an organization block, then it will not be used. Because here we want to use organization blocks, so we need to find, is there an existing OB? So we have a check in our PLC device, find blocks by attribute, number, and so on. And as I said, these OBs, they always have fixed numbers, so you can easily find them here. But you have to be careful because it's possible in tiaPortal for FBs to have the same number. So by these find blocks by attribute will give you all blocks with that number. If you happen to find an FB with the same number, then you will get this FB instead of, or you might get the FB instead of the OB. So in case, like normally it should find a OB first, But if it doesn't find an OB, it might find an FB, and then you don't want to use the FB. So here you have this extra term where it basically says, okay, is it even an organization block? And if it's not, then do not use it, and existing OB remains null. And then after you found out if an existing OB already exists or not, it's time to deal with that. So here we have basically the distinction. If we have no existing OB, then yeah, things are rather easy. We go here, in this case, it says, okay, we go to programming language FBD. That's kind of default here in this case. You can also set it to STL if you like. We create the block as a file. So we have added this block, this XML logical block. We generate an XML file from it, and we can give the programming language. In our in our case, it's FBD. So we create XML file for the programming language FBD for this OB, and then we generate the block. And this is done. I've shown you this twice already. This is basically done as you have seen it before. Here, of course, we always use XML because we have generated an XML file. So we always will generate this block as not as STL. The rest remains the same as I've shown you before. And when you are adding it to an existing block, here's what you do. Like first, I will. So now here we go. First, we export the existing block as an XML. Therefore, the modular application creator provides you with a function. So you basically just say, okay, which name does it has? And then, yeah, it will find it, export it. You will get the block as an, yeah, in this case, as a X document. You will create an XML block from it, like the X document will be used, and then we have this parser again. This parser is possible. With this parser, it's possible to pass, in this case, for example, an X document to an XML, as I've said. And later, or in the next step, we will merge those blocks. So here we have the XML OB. This is an XML block. This is, as I said, the XML block structure that comes from the modular application creator. And we can easily merge that together with some other XML block. So here it works for XML block and XML logical block. So that's not a problem. That can be done with this Mac internal function. And the result that you have is this XML OB. And then basically you have a check, okay, look, okay, what is my target programming language? If my XML OB already has the programming language SCL, then I will generate an SCL file and generate a block in SCL. Otherwise, I will generate an XML file with the FBD language and generate the block in FBD. Here it's important to understand that this XML OB block attributes programming language, and that comes from the exported block. So basically, when you have an existing OB, in this case my OB1, it exists already. So I already have an existing programming language, and I want to merge my new generated blocks or my new generated calls into the existing language. So I will have to go with the existing one, and that's the one that is being used here. So it basically checks, is the programming language SCL, then we do this part. If it's FBD, then we do that part. And yeah, that's all the magic. So you can see that here you get a lot of very nice additional functions within the modular application creator that makes it easy for you to include your own code into existing structures. In this case, you don't have to care whether your existing OB is an SCL or FBD. You can just add it, and this parser will help you in in parsing from one programming language to the other. It's a bit more complicated, this parser. Maybe I will have there might be an own getting started video about how to use this on its own, because there are a lot more functions to it that would exceed our current scope. But here you can, I think with this, in this case, you can see a couple of very useful functions and how it can be used and how we actually use it to parse, for example, this SCL call in an arbitrary function call, and later we can then create function calls for FBD or SCL or whatever we want from that. So that's quite powerful. And if you want to do this on your own with openness and normal C# functions, you will spend quite a lot of time realizing this. So here, the modular application creator can really, really help you out. So now we have finished our function. You can see there's no compiling errors anymore in our Visual Studio project. And now, as it is in all the other cases too, we need, of course, to call this function in our generation routine. So here, I will add it directly after the GenerateDB. Again, the PLC device and the module goes into it. And that's it. So now we're actually quite advanced with our generation now. We can generate technological objects, we can generate TagTables, we can generate data blocks, and we can generate our OB1, which is quite a big achievement at this point. So now we're almost done with the important parts. There's only one topic missing or one topic left. This would be, how do I actually generate values into my data blocks? And this will be explained in the next step. So in the next step, we would like to fill our global DB that we have created with actual values. So far, we have created this data block. We have set up the name of the variables inside and the data types, but so far they will always be generated with their default values. So we need to find a way to actually bring our required values into this data block. So I will show you quickly in the TiaPortal project what we are planning to do. So here, as for this example, we'd like to preset certain values in this data block with values from our data model. So specifically, we would like to set this velocity leading property, velocity jog start pods saw property, which we can find in our global DB, FlyingSaw dot basic control dot inputs dot and then the properties that I just mentioned. Same goes for this sync length auto and this max pause to cut. So you can see they are part of our global DB structure. They're like properties that we will have within our FlyingSaw property of the given data type. And we would like to set it to some values from our project. So how are we going to do this? Within the modular application creator, we have a quite nice feature for this. And this feature is called TiaAttribute. So in order to use this TiaAttribute, we will first have to create those TiaAttribute. And in order to create those attributes, we need to first create it within our cutting axis and our infeed axis, for example, or like basically anywhere in our data model. So we need to make some changes there. Like currently, for example, we have this maximum cutting position already here. So this is a value that we would kind of like to use for our cutting axis. In our infeed axis, we have this maximum velocity. We will also use this, but we will need to use it in a bit different way. So we have to make some changes to our data model. And these changes are quite simple. Like here, what we do is we replace this string that we currently have, which is a string with given default value. We replace it with our TiaAttribute. The TiaAttribute is a class, as I said, given by the modular application creator, and it gives us quite some powerful functions that we will use later. So now we created this TiaAttribute, and as I said, there were 4 properties that we would like to set. So 2 of these properties are within our cutting axis, 2 of them are within our infeed axis. So here we are in our cutting axis and we have to add something to it. The next property, like we have this maximum cutting position. This maximum cutting position is, let me see, it will be this max pos to cut. And the other value I brought in is length cut auto. I just call it length cut auto. That will be this value. So here we are having our values, as you can see in the lower part of our data block. And we do a similar thing for our infeed axis. Here we have the maximum velocity. Currently it's a string, and we basically do the same as we have done before. We add these Tia attributes. So I remove this maximum velocity and add my Tia attributes. I've named them a little bit different, but it will not make much of a difference. Like velocity leading and maximum velocity will be kind of the same. I just name it a bit different now because this it's supposed to resemble quite a bit better how the name of the values in the data block are. But basically, you can also give it different names. This name has nothing to do with the basic function of it. So we made these changes now to our data model. And of course, we need to make some changes to our view models too. So I go to my cutting axis, for example, here. You can see, okay, this maximum cutting position, it does not exist anymore. And this is okay, because we will make a little change to it. I will change the getter and setter accordingly, so we can actually use it again in like similar way like before. And here you can see what we did. So this maximum cutting position now is a TiaAttribute. It makes sense to maybe have a look at this, what actually this TiaAttribute is. So I will give a short introduction into it. As you can see here in our view model, we now do not, we're not setting this attribute itself, we're setting its value. And yeah, this is quite important because the value is what is interesting for us in this for this scenario, but it might make sense to have a look what this TiaAttribute is actually about. So this TiaAttribute is kind of a class that you can use to create those attributes or those properties within your TiaPortal project. So it has some specific functions for that and properties as well. Like for example, here you have the Tia type. The Tia type is very much resembling the types that you know from your TiaPortal project, and it defines what is the required type that you want to have in your TiaPortal project. So this needs to be the type that this value is supposed to be to become within your TiaPortal project. So we can have a look, for example, here we have, for example, this velocity jog start pos saw value, and this is an L real. So obviously for this, we wouldn't have to make it an L real. Same goes for our velocity leading, this sync length auto that we wanted to set, and this max pos to cut. So they're all L reals. So we will be required to use L reals types there, but you will also be able to find other types from the TiaPortal. So here you will be able to find all your TiaPortal data types, or at least the most common ones, and you'll probably be able to recognize them. So yeah, I think this is rather simple. Then we have a thing like the target name. Target name means that you define the name of the how do you say, the element that you can find your property in. Target name in our case would be the name of our global DB. So you have to give like the full name of the global DB. Getting started.globaldb would be in our case. Then you have the attribute name. This will be the name of the attribute within those data block. So in our case, the attribute name, for example, for this, let's say, this velocity leading would be FlyingSaw dot basic control dot inputs dot velocity leading. So this would be the attribute name that you have to set. So with the target name for this DB and the attribute name for the attribute, it will be able to find it within your TiaPortal project. And what is also important is this source type. Source type, basically you have two different enums, block var or tag. So yeah, it's either a tag in the tag table. So you will also be able to set tags in the tag table this way. I've shown you how to set to create a tag in a tag table when we're looking for existing tags. But here, when we're looking to create new tags, but if you would just want to alter the value of an existing tag, you can use this TiaAttribute as well. And it works totally the same, like I show you now for a DataBlock variable. You can use the total same concept to create a tag. So in our case, we go with this block var source type, and this is basically what we need. So yeah, this is the important attributes for us. And of course the value, because this will be the value that we have to write into our TiaPortal project. So obviously we want some value. And the other functions that we have here, we will look at them later. Like for example, this upper or lower custom bound, they are basically there for validation. And this validation will be important in a future lesson. That's when we get to the topics of setting up the UI and writing code for the validation of our attributes. So it's mainly for trying to validate the attribute within our UI so that the user gets a feeling if the value makes sense. So for example, if the value is supposed to be lower than 100, then you can make a validation that triggers a kind of an error to the user, like in a UI, and then the input field will become red, and it tells you that you will get that you're out of the bounds for this specific property. So this will be important then. Similar things like the validation result are for that, and also these functions. We will need a few of them, but most of them are, let's say, for more advanced use case than what we are trying to do here. So for us right now, as I said, it's important this tier type, this attribute name, source type, target name, and value are the attributes that we are focusing on. And yeah, that's what we are going to deal with. So let's go back to our view models, because this is basically where all the magic is going to happen. And what we are going to do is, first of all, as I said here in this cutting axis view model, I was already changing the axis to my property maximum cutting position to make it the value of my tier attribute. So with this property, we can easily set the value. We can just say, okay, cutting axis view model dot maximum position, maximum cutting position, and give it some value. And the value will already be used for this tier attribute. So this is already what we want, but we have to do a little bit of extra work now in our, let's say, constructor methods, or like basically you're kind of free to make these next changes wherever you want. I would strongly recommend to do it close to the constructor or within the constructor, but of course it can be quite use case dependent to say where it might or might not make sense. So yeah, one thing maybe I should mention, like as we have seen, we have this maximum cutting position as a property here in our view model. But if we go back to our actual data model, we can see that we also have this length cut auto. And so far, we do not have any setter getter for this property. And for now, we are quite okay with that because this property, I mean, in the end, it's just accessing the property on my data model, which is fine, but it will mostly be used for later use within our UI. So we have this getter and setter basically to later use it in our UI, so the user can set up this value. And for now, I just define and say, okay, this length cut auto, this is a value that will be quite static and we will not make it changeable from the UI. It will be, let's say, it will be calculated from values that might be possible to be set in the UI. So the user does not need to change this directly by himself, but he will get kind of a value that is dependent on other parameters. So this is why we do not need such a getter or setter, because we do not need to access it from outside, but only through, let's say, inside methods. So what we now do is to extend our create new model function. So right now it only returns a cutting axis, which is basically okay, but we need to add a little bit more. And we need to add some functions for our TiaAttributes. So first of all, we need to create a list of TiaAttributes. This will be very crucial for later steps that I will show you when we get to the actual generation in a couple of minutes. And you can see, okay, this attributes isn't even existing. So, okay, that means here we have to create it, obviously, in our cutting axis. But since we say, okay, it's not only the cutting axis that's supposed to get these TiaAttributes or to use these TiaAttributes, we could already go, let's say, one step back and say we go to our axis base model and say, okay, this is actually our base class. And since all our classes are supposed to use these TiaAttributes, we should implement it at this point. So what I'm doing here, I'm implementing the interface, and this will be very important. This is a very crucial step you should not forget. It's called TiaAttribute user. And we can get it from the Modular application creator. And it tells you, look, it needs to implement these attributes. And so this is what we do. We use the implement interface function, and here we go. We get already our attributes list. Here it says, okay, it's not implemented. So we make some easy implementation, make a automatic getter and setter. And this is all we need for these attributes. So now we have a list of these TiaAttributes within all our classes that derive from the base model, which will be our cutting axis and our infeed axis. So now they already have these attributes list. There's nothing more to do in these classes. And if we go back to the functions from our cutting axis view model, we now see that here everything seems to be working fine. At least there's no compilation error. So we can go through that actual methods. First, we initialize this attributes list. I think this is quite trivial. And what we then do is we create these TiaAttributes that we're trying to use. So as you have seen, we have already defined those attributes as basic, let's say, properties here, but they're kind of empty properties. They have to be initialized, obviously. So for TiaAttributes, it is a bit of a special way. because we have to use this TiaAttribute provider class and use this create attribute function because there's quite a bit of logic behind to create such a TiaAttribute. So here we first of all give it Tia type. This will be a real, as we said. We have this block var source type, and you can see there are two empty strings that we're adding here. And these strings, if we look at the definition for our function, we can see that these empty strings are the target name and the attribute name. And so why are they empty? You're probably wondering. And the reason is simple. We do not know at this point what will be these names. I've shown you that here in our TiaPortal project, we would like to include them in our global DB. So the name of the global DB, I mean, it will always be something called something.globalDB, but we do not know what this something is. The something is the instance name of my module. We've talked about this before, but this can change. So in the time that, for example, at the moment when you create this model, there will be a name for this module existing, but this name could change before you start the generation. So there could be a case where you actually create this attribute, like for example in the constructor of your module, but then throughout using the modular application creator, you decide that your module should get a new name. So you change the name, and then you would always have to change the name here too, obviously, because here the name of this target would change depending on the name of your TI equipment module. So what we're doing here is we leave it blank and we fill it out later when we can be sure that the name of our target is fixed. And the same goes with our actual attribute name. And this is also because the first entry in this DB, or the first level of this DB properties are named the same as your FlyingSaw. And also the name of your FlyingSaw could change when using the program. For example, at some point you decide, oh, the name FlyingSaw is not sufficient anymore. I have to name it FlyingSaw upper or FlyingSaw lower or FlyingSaw for customer X or something. And then, of course, the name of this whole attribute would change because this first level name would change. So we cannot be sure when we create this attribute what will be the name for this. And that's not a problem because this attribute and target name will be required at the generation. Before, it doesn't matter, but during generation it will be required. So what we do is we will make sure that we will have that name before the generation of this attribute starts. So next thing is, oh no, hang on, there's one more thing that I was forgetting. This will be the model. So here you give it the model, which is our cutting axis. And this is important because this TiaAttribute has to be, let's say, registered to a TiaAttribute user. So my model is my cutting axis, and my cutting axis, as we have seen, is deriving from the base model, and this includes this TiaAttribute user interface. And this is very important because here when I trigger this create attribute method, it will register my attribute automatically to this attribute user. So it will then appear in my model.attributes list. And this is quite important because later this list will be used to gather all the TiaAttributes from your class object in order to generate it into your TiaPortal project. So that's why you have to add this model to it. If you are an advanced programmer and have some experience, you are also free to modify this attributes list. There might be use cases where you want to exclude attributes from the list because maybe it's not important to generate them, or maybe you want to include some from some sub-elements. That would be possible to do. So if you want, you can do some try around with this, play around a little bit and see what the result will be. But basically, this attributes list is your reference for the TiaAttributes that will be generated later. And I will show you at what point and how they will be collected. So yeah, so it's important to add this model here for this create attribute function, because then you, as I said, it will be registered into your TiaAttribute list. And then you can define a value for it. Here we define the default value will be 250. And then we have this length cut auto. That's what I said. This will be a variable that will not be accessible in the UI. So what we do now here is first step is similar to the one before. We define type. We define it as a block var, and then we leave the target and the attribute name empty for now, adding the model to it. And that's basically it. So now we have created our tier attributes for this cutting axis. And they can be used. And for example, this maximum cutting position can be easily accessed via this getter and setter. So I think this is pretty straightforward. What we have to do now is do the same thing for our in-feed axis. So within our in-feed axis, you can see, okay, we have this maximum velocity that we were accessing before that, of course, needs to be changed a little in the same way like we did before with our cutting axis. So I would just replace those values with the model velocity leading dot value property. So I think this is pretty much none at this point. And now we have to do a similar step like we did before in the constructor, or in this case in our create new model function. You remember that this function was actually is created in the constructor of our base class. So now we are adding the required scopes to our project, to our class, so that the tier attribute is recognized. And then we basically do the same steps as we did before. And what we do here is that we say, okay, we have this, we create these attributes, we have this velocity jogs start pos saw and velocity leading. And yeah, that's basically all that we need to do. And what we do here is that, we could also give it a start value for our velocity leading value. So I think it was before, I'm not sure, but I think it was 100. So let's just put it to 100. Oh, no. And these value properties are always strings. So that's what we do. We set them to a string, in this case 100.0, and then we are basically done with this part. And here it's a bit similar like before. This velocity leading, which is what our maximum velocity was. This is a value that we use in the UI. And this velocity jog start pos saw will be a property that we will not access in the UI, but we will automatically set it to a value based on other inputs, basically. It will be very trivial and simple, so do not expect too much magic there, just to kind of have distinction between values that come from the UI and values that can be, how do you say, calculated internally, let's call it that. So now we have set up these tier attributes, and this is at least for the initialization, this is basically what we have to do. And now, as I said, we have to find a way to set this target name and attribute name that we left blank before, because we do not know what will be the actual values for the generation. And in order to set these values properly, we should actually set them at a time where we are sure that these values will not be able to change anymore. And usually this time is during generation, because when the user presses the generate button, that's when the kind of UI gets disabled and the user cannot make any changes anymore, and everything is being generated. And at this point, it is clear how these values will look like. So names and everything will be defined at this point. So it would very much make sense to have some way of accessing those objects during the generation in a way that we can say, okay, we know what's going to happen, and we can access it in the generation phase by adding some functions or code into our, let's say, for example, in the view models. A way that I quite like to do is, for example, to create some kind of before generate method. So what I mean with this is, for example, we start here in our FlyingSaw view model, and then we define a function before generate. So we have this before generate. At this point, we leave it empty. And what we do is we go into our generation routine, and we have this initialization phase. So as I said, this initialization phase is basically to initialize, for example, libraries or other properties. And this is a very good place to have our actual before generate function. So what I'm going to do is just adding a for each loop, for each FlyingSaw. I say call this before generate. So, and this before generate, of course, it doesn't do much now because we haven't added anything. So what we do is we will add a similar function to our axis base view model in this case, because we will need it in all our axes. So let's add it here. For example, we make it virtual so we can override it. And yeah, that is, for this point, that's enough to add it to our FlyingSaw view model. So here what we can do is we just call the before generate of our infeed axis and of our cutting axis. So during generation, we now call this before generate, and then we call it before generate for the infeed axis and for our cutting axis. And now the question is, what will we add in these functions? So point is easy. We go, for example, we start with our infeed axis, and we could define something like, oh no, let's stay with our axis-based view model, because we know that for both of our axes, the cutting axis and the infeed axis, we will need to make adjustments to our TiaAttributes. So I would very much recommend to have a function to prepare a function that would make this possible. So for example, the function could be called, let's say, something like this: update TiaAttributes and add global DB name. Global DB name, I told you, is important to define the global DB name of these of the global DB basically. And a few more settings have to be made for our TiaAttributes that will be done within this function. So, and how does this function look, or how could it look? Oh no, one thing. Basically, what we should do. No, we cannot add. I wanted to actually add this function into the before generate, but that might not work so well because this requires the DB name as a string. So I would suggest we even split this function a little bit and actually add this function also to our FlyingSaw view model. And I will show you quickly why this is done, and I think this will be simple to understand. And we do make a similar concept like we did with the before generate, and then we call it in a similar way. So let me show you what I mean. So we have this update TiaAttributes and global DB name, and now we're getting to our generation routine. We just have we add another for each loop with the update and get Oh no, hang on. Get global DB name. With our module name. So it's basically looking like this. Yes. I think this should contain all the information. Now you might be wondering why we have another for each loop. We could also call this function here in this loop, and basically in this case you could, but maybe there might be cases, maybe the before generate contains some let's say some routine that needs to be finished before going into this update TiaAttribute functions for all the flying saws. It's not the case for our example, but in theory it could happen, so it's never bad to split those functions, in this case at least. So now we have these both functions that we are calling in our init phase, in our first init phase, and both of them will have their own functions. So we will have some specific functions for the before generate and some specific functions for this update TiaAttributes and add global DB name functions. And you will see in a second why this is not a bad idea to have them both. So as I said, we go into this update TiaAttribute function for our infeed and cutting axis. And here we can go, okay, we have this axis-based view model. This is this virtual function, so we can override it for our specific view models. And here I would start with this infeed axis view model. And what I would do is basically saying, okay, we have this update TiaAttribute function, and what I will do here is adding the following code. And you can see what it kind of does at this point. We set our target name for our velocity jog start pos saw attribute. We set the target name. This will be just the DB name. The DB name at this point will be fixed, so we can set it here. And the attribute name, as you can see, is also being set. And you can see here we have the parent.name. The parent is our FlyingSaw view model. So we have the FlyingSaw name dot basic control dot inputs dot velocity jog start pos saw. And this is exactly the path you can find here. Let me see, where is it? Here we go. So FlyingSaw dot basic control dot inputs dot velocity jog start pos saw. So this is the path to our attribute. And again, as it is kind of the case for all of TiaPortal, it's very important to make sure you have the right spelling. So do not mix up uppercase and lowercase letters. Make sure you always have the right spelling, because even one small mistake, one uppercase instead of a lowercase, makes the TiaPortal unable to recognize it, and you get a generation error. So yeah, that's important, but I think it's quite straightforward to see what happens here. And what we do here with this velocity jog start pos saw is that we give it the same value as our maximum velocity. So it just takes the same value like we have set for our maximum velocity for this, which is the velocity leading property. And we basically just give it the same value. So we say both of those are supposed to have the same value after generation. And we do the same for this velocity leading. Here we only set the DB name and the attribute name because the value has already been set. That's the value we have set in the constructor. And later we will be able to change this value from the UI. So we can be sure there will be some kind of value here. So we do not need to set any value. So this is what we need to do for the TiaAttributes in this case. I think that's not so difficult. And yeah, the same thing will happen for our cutting axis view model. Here also we need to implement this function. In this case, we make it a bit more complicated because we have our what's it called, length cut auto property. So what I'm going to do is, first of all, I'm setting this maximum cut position target name. I think this is same as before. That should be simple. The attribute name also should not be too hard. For the length cut auto, it's also first steps are, I think, simple. And then the question is, how do we set the value? And here we make a bit more of an, let's say, more complicated calculation, although it's not very complicated, I guess. And we make it dependent on the material type. This material type is a value that we will later be able to set. Right now, we do not have a getter or setter for this. We will include this once we are looking at the UI, and we will make it possible to set it with the UI. So we will look at it later. Right now, this value still exists. And of course, we want to do something with it. And in this case, we say, okay, we have this length cut auto value is dependent on the material type. So we just define when we have aluminium pipe, we say it's 200. When we have steel sheet, it's only 100. So this is fixed. It's either 100 or 200, but as I said, it depends on the material type. And yeah, that's how we define it. And in the end, we set the value to this, let's say, calculated property that we have here. So I think this is quite simple to understand. So we just have a bit more code to determine this value. And other than that, it's really the same procedure as before. So now if you look at our routine, we have our generation routine. The before generate currently it has no function. I will get to that in a minute. But our update tier attributes and global DB name function is working, or supposed to be working fine at this point. We call it within our FlyingSaw, and the FlyingSaw calls it for the infeed axis, which then does this part, and the cutting axis, which is doing this part. And here everything, all the properties are clear. The DB name is clear. It will not be able to change. The parent name, like the FlyingSaw name, is clear. And of course, this material type can also not be changed at this stage of the program anymore. So this is functioning then. So here we are pretty much done. Only thing we need to do is to actually make sure that our TIA attributes are being collected and written. So you might be wondering, where is that going to happen? Because so far we haven't done anything and didn't write any code for that. And you might have noticed that within your TiaPortal project, not your TIA, your modular application creator project, that we created in the beginning when we created this Visual Studio solution, and this whole function, this GenerateTiaPortal function, was created automatically. That there was already one function here that you can see, which is called provider.collectAttributes, and you have this provider.writeValues. And probably until now you weren't sure what this is actually doing, and now you might be able to understand that this is actually the provider for our TIA attributes. If you hover over it, you can see that the name is actually TiaAttribute provider. And this is a class that will help you in writing your TIA attributes. So it collects all the attributes from any given class, kind of, and then it would write the values. So what we have to do is we have to make sure that it collects all the attributes, and then with this write values function, it will automatically write them to the PLC that is selected here. So for here, you do not have to make any changes. You can see it already collects attributes from some attributes list, and this is basically the attributes list of your equipment module. Each equipment module has already this attributes list included. So you could use TIA attributes on your equipment module. That's easy to do. There's already an implementation for it. So if you have TIA attributes on this general level of your equipment module, that's possible to do. But here we will not quite do it. We have, let's say, TiaAttribute users on a lower level. As we've seen, our cutting axis, now infeed axis, are the TiaAttribute users. And of course, we could say that these TiaAttributes could also be part of this attributes list of our module. We could add them to this attributes list, and here it would be collected. That's perfectly possible to do. But I like the, let's say, a bit cleaner approach to say, okay, we have these attributes within our sub elements, in this case, our cutting axis and our infeed axis. And in order to do that, we just have to add a small function. As we always do, we say we create a for loop for each loop for our FlyingSaw. And then we say, okay, collect the attributes from our FlyingSaw infeed axis and cutting axis, collect those attributes. And here you can see we haven't actually given access to the view models to these attributes. So this is something we have to do, but this is very simple to do. We can do it quickly, and I would very much suggest doing it in the access base view model class. And what we do is we just include one little property. It will look like this. Here, need to give the reference to this tier attributes, and then we will be fine. So basically, we're saying here this attribute gives you access to this model.attributes list. So with that little change, we should be fine. So here you can see in our generation routine that we now don't have compilation errors anymore. The provider collects the attributes from our FlyingSaw infeed axis and FlyingSaw cutting axis for each FlyingSaw that we have created. So by the way, it doesn't matter in which order you have this collect attributes function. So you could either have it here, you could move your general collect attributes function up, or in our case, as I said, we are not using this attributes list from our module at this point. So far, we don't have any use for it. So we could also comment that line out. That would not have any effect at this point, but yeah, we can just leave it there. I mean, it doesn't have any effect, but maybe if we add some attributes to our actual module directly to the module class, then we would need this. So we can just leave it here. It doesn't do any harm. And once all these attributes are collected, like we do it here, we have this write values class, write values function. This function writes the values into the PLC. And of course, I think this goes without saying that this is supposed to happen after the collection has been done. So if you move this up here, for example, then it will try to write those values that it has collected until this point, which will not be any because all the collect attributes happen later. So then you will not have any values written to your PLC device. And in this case, of course, nothing will be written, so you will not have any effect of it. So what we want is to have it down here after all the collection is done. So, and this is all the magic. Now our tier attributes that we have defined, they will be written into our global DB. And so this is basically all that there is. And you're probably wondering, why did we even include this before generate? Now we're not even using it. Why is it there? What's the purpose of it? And this is in order to show you one other use case for this. Basically another use case on how to deal with writing values. Because so far we have now written our values into our global data block, but you might have noticed that so far we haven't written any values into our technological object. We're creating the technological object, but we haven't really looked at how can we actually get values in there. Like if I want my technological object to have some values that are not default values, how would I be able to do it? So far, we haven't looked at that. And that's what this before generate method is for. And I will show you this quickly on, let's say, one example. And we do it with the infeed axis. Here we, for example, we said, okay, we have this maximum velocity. This maximum velocity property, this is being written into our global DB, and this is where it belongs. But maybe we also want to write it in our technological object. So for example, we have our infeed axis here, and since it has, as I said, it has the property, so we would like to also write the technological object property. And the technological object, of course, it has a lot of properties, and each of them, yeah, or many of them have the possibility to be written. So we first have to find out which property do we want to write and what is kind of the path for it. Because if you look at TiaPortal, you can see that your technological object also has a DB number. Like here in my case, my infeed axis has the number DB4. And it functions in quite a similar way like other DBs function, or it has, let's say, a similar structure. And so this way we can also, or we have to actually also determine our, let's say, properties that we want to set in a similar way. So first, it oftentimes makes sense to look at the UI view via TiaPortal technological object to see what do you want to set. And for example, for us, we say, okay, we have this maximum velocity. So we want to set this maximum velocity. So here you have it in dynamic limits, maximum velocity, and this is what we want to set. So here we can see it currently has the value of 100. And this can help us in identifying what might be the path to this value in the DB of this technological object. And for this, we go into the parameter view. And the parameter view already kind of gives you a filtered view depending on what you selected on the left side. And here you can see that you can find values like dynamic limits, maximum acceleration for the dynamic limits, maximum velocity, and yeah, many more. And normally you would be able to find the name in the data block on the right side. Unfortunately, that doesn't work for every parameter. I do not know why that is. There probably are some reasons why they're not showing it. But for the ones that that they are shown, you can just use it here. And this is basically the path that you need. So the name of your DB would be the name of your technological object, and the path in the DB, similar to how we had it in the global DB, would be shown here. And what you can do is, if you do not find the value here, you can have a look at it in the Openness Explorer, for example. There you can get a better view on those paths, for example. So I would maybe take this chance to give a little excursion into the Openness Explorer, because I think here it's very crucial to understand where your paths are coming from. So the Openness Explorer, in case you haven't used it, you can find it on the CIOS page. There's also I think there's also a little tutorial or documentation about it, so I don't want to get into much detail how to use it. But I would like to show you where to find the required data for this use case. So what we do is we open the Openness Explorer, and then we will go to the technological object that we're looking at. So here, that's quite a bit of passing through this project. It is not very trivial, but as I said, I think there's good documentation for it, so I don't want to explain too much what's happening. Probably in many cases you can do similar steps like I do. If you're not too familiar with it, just try to find your PLC and your device composition or device user group composition. Once you found the PLC, get your software container service. Invoke it. And here you have to scroll to the technological object. So And here we go. We are looking at the infeed axis. And once we have done that, we get into this parameter composition. This is a very long list, and yeah, it's not always the easiest to find your values. In our case, it's not that difficult because we are looking for dynamic limits. So here we have this dynamic limits name dot, in this case, maximum velocity. So yeah, this is probably our value that we're looking for. And if you're not 100% sure, then oftentimes you can have a look at the value. Here it's 100. And as I have said before, if you look in our TiaPortal, we also have the value 100. So this is kind of a way to find the right values sometimes if the path is not very clear. It doesn't work for all the cases, but it's, let's say, a good rule of thumb. So here you can find your parameters. In this case, we found out that our parameter that we're looking for is called dynamic limits dot max velocity. And this is what we need. This is basically the path that we need. And it's theoretically possible to set those TO parameters also via TiaAttribute in a similar way like we have done before. So that's not a problem. You can set them like other DB variables. But there's an easier way that is provided by the modular application creator. And this is why we need this before generate class. And I will show you how this is done for the infeed axis. So I'm adding this function here. And here in the before generate, first triggering the base.before generate in case something is happening there that's important. Yeah, we could actually do the same here too. Since for us, it's not, we know that nothing happens, so it's not required to have it, but I think it's the cleaner way to always call the base function of this too when you override, except if you're sure you really don't want to use it. So here we also have the base, but this is, yeah, just very basic. And then we have this TO path. This is important because the TO path is the one that we have found so far. This is the path we found in our dynamic limits dot max velocity, this parameter, and this is the path to it. You can also find it on the right side up here. And this is what we have to set. It's basically similar to our attribute name. And what we can do here is we don't have to create a TiaAttribute for it. With the technological object, we can directly go into the technological object, set the additional parameter. That's a property that every technological object in the modular application creator has. And here we set the TO path in these brackets. And basically what it's doing is that if it doesn't have this, like this additional parameter is kind of a dictionary with a string for the TO path and a string for the value that it's supposed to be written. And if this, for example, the path doesn't exist, it will create it in the dictionary and add this value to it. If the path already exists, then it will just change the value to the given value that you set up here. And this is basically all you have to do. So within your technological object class, you can define all additional parameter, all technological object parameter here in this list. And you can do this for all the parameters that you have here. So you have, for example, your parameter view, or you can use the function view and see all those parameters that your technological object has, like acceleration, deceleration, or other parameters like here, number of motor revolutions, or what are other parameters like, for example, this modulo, enable modulo, and you can basically set all those parameters by finding them here in the, for example, with the openness explorer, or you can, for example, write your own little openness application which lets you scroll through those parameters in order to get the names, however you like it. And once you have the name of the parameter, you can give it also a value and basically do it like we did here. And these parameters are being stored in your technological object class. And that's all you have to do. So now when we call this before generate class, now you know that it has a use. It's called from the FlyingSaw. Then it will call the infeed access before generate, and here it will set this TO parameter. And as soon as this create TO function is being triggered that we have created before, it will create this technological object, and then it will set all the parameters from this additional parameters dictionary that we have set up in the before generate class automatically into your technological object. So in this way, you can create the parameters into your technological object. You could also use the TiaAttribute for it in the same way like we have done for the global data block. But I think it's the easier way is actually to do it in a similar way like here. Like you don't have to do it in the before generate class. If you know that, for example, these values won't change, they're always fixed, and you could, for example, also do it in the constructor and set the values here at the point where you create a technological object, which happens. I have to see. Yeah, here, for example, when you create a technological object, you could instantly in the next line say additional options for whatever parameter are being set to some value. Of course, easily possible, but if it's values that, for example, are dependent on UI inputs, then of course it makes sense to set them, for example, in the before generate, because that's the point where you are sure that you have the final value for this and things will not change. So yeah, it's a bit use case dependent, as I said, but there are different ways on how to get it done. And as I said, also you could also use the TiaAttribute if you feel more comfortable with it after doing it here in our with this collect attributes and the initialization for that before. So this is the end of our lesson today. I think we had covered quite a lot of topics. So just to give a brief summarization of what we have done, we first of all created all the TOs, and now you have seen how to set up parameters for the TOs, which will be done in the before generate class, generate function. The TOs will be created here automatically. Then we were creating this TagTable and adding text to it. We were generating this global data block, and with our TiaAttribute, we were adding values into our data block. We created our OB1, and for that we created our own function call that we then were calling in the OB1. And yeah, I think this is pretty much it. Yeah, and we must not forget we also created our TiaPortal library into our project, which I think is quite a big achievement that we have gotten so far. And with this knowledge, you will be able to create quite big and powerful TiaPortal projects with your modular application creator module. So have fun, try out, and if you have questions or looking for more advanced functions and use cases, feel free to contact us anytime. You can find our contact on the CEOS page for the modular application creator. I think there's usually a contact name that you can contact, or an email address for our team mailbox, and we will answer, of course, to questions usually in a short amount of time. So feel free to ask questions, or if you have suggestions on what to do better or suggestions for other tutorials, feel free to give us feedback. We're looking forward to it. Until then, have fun and yeah, enjoy the modular application creator.